Cool. Hey, good morning, everyone. Thank you for good morning. Thank you for making it here, especially today when trains are on strike. It's been a little bit difficult. We didn't quite know how many people would show up. We're thankful that over 100 people signed up online, and hopefully we'll be seeing them throughout today. Maybe here in person, let's hope, or online as well. But we have a set of fantastic talks lined up from all kinds of different Azure topics. So things relating to AI, things relating to container apps and the PaaS side of Azure, functions, data, a hell of a lot more. So OpenAI, yeah. So much stuff coming up. It's going to be a really great and packed day of learning. I was just going to tell you a quick bit about Global Azure. So Global Azure is a community organized initiative. We have, I don't know how many events are actually happening all over the world right now, but various different local events. And this is our only event happening here in the UK. So yeah, this is great. By a quick shout out, and maybe people in the chat as well can let us know, who here has come the furthest? I know the answer, but I'd love to know where you've all come in from today. Where have we traveled from in the UK? Wembley. Wembley, that's very far. Northern Ireland, Mark at the back, that's excellent. We have a winner here at the front, but yeah, Auckland, New Zealand, very impressive. Thank you for joining us, Will. And again, yeah, in the chat, let us know where you're calling in from. I know that people are not just in the UK, but all over the world are going to be watching this event today. So thank you for joining us. So I wanted to just quickly mention something that's really important. We want to make sure this event is a safe space for everyone involved. It's a nice, friendly environment where everyone can learn. So there is a code of conduct in place. You can go to globalazure.net, where the code of conduct is there. By signing up to this event and by attending, you are agreeing to comply with that code of conduct. If you have any issues with anything throughout the day, and this includes people online, let us know either in the chat, or you can approach myself or Poornima here at the front. We will do our best to help you out. Some logistics for the day. We have, I think, 10 talks. We have coffee breaks as well throughout the day. There is coffee and tea at the back. If you're at home, there is probably coffee and tea in your kitchen. Go make yourself one. We'll have a lunch break, but during the breaks, there's also talks. So we have a couple of virtual speakers who will be doing sessions during those breaks. So you're more than welcome to have a chat network at the back of the room, or you can come in here and you can watch those virtual sessions as well. Something else that's pretty exciting is Microsoft has very kindly offered some of the events, some of the Global Azure events, some free Azure passes. This is $100 of credit that you can use on Azure to play around, maybe explore some of the cool things you're going to see today. These are really, really limited. But if you'd like one, come and chat to myself or Poornima. We can tell you how you'll get access to this. It's on a first come, first served basis, like globally. So if you do want this, yeah, let us know, and we can help you out. I guess if these don't get used, Microsoft won't sponsor as much next year. So in some ways, it's better that we use them all. So yeah, please let us know. This is going on the Microsoft YouTube channel, so hopefully they don't mind me saying that. Fantastic. Yeah. So I think without further ado, we can hand over to Will, who's going to be talking a little bit about container apps and microservices on Azure. Let's give Will a round of applause.
Hello. Can everyone hear me? Fantastic. looks like I'm on. So I've got to present. I'll share the... Share that screen. I'll present that. Is that coming through? Awesome. There we go. Sorry for the world-class vamping there. Welcome. Good morning. Hello, everyone, and welcome to Global Azure Bootcamp London. My name is Velida. I am a customer engineer working in the Fast Track for Azure team, Microsoft in New Zealand. I haven't come all the way from New Zealand just for this. I mean, it's great to be here, but I wouldn't make that flight for one day. I'm originally from the UK. I'm speaking at Techorama next week. So if those of you in the room are going to join Techorama, it'd be good to kind of hang out and see you there. But today, here at the Global Azure Bootcamp in London, we're going to be talking about developing and deploying containers and microservices with Azure Container Apps. A nice, succinct title for all of you. Just in the room and online, maybe just put a comment. How many of you have played around with Azure Container Apps? Whether it's just POC or working production. Okay, about half of you in the room. That's good. And how many of you, like coming from a Kubernetes background, not necessarily AKS, but could be any cloud, even on-prem. Awesome. A couple of hands. Cool. So today I'm going to start by going over what are Azure Container Apps at a really high level and what kind of applications we can actually build with container apps. Then we'll go into a deep dive. I've only got half an hour, so I say deep dive in inverted commas, because there's probably not enough time to go dive too deeply into how, well, the different components of container apps and how we can actually use the various different components and keep those in mind when we're actually building apps to deploy to container apps. Then I'll dive into a demo, which is going to work, even though I've had some interesting problems this week with various components of it, but it's going to work. It's fine. It always works on the day. And I'll show you, use an example of blue-green deployments and how we can actually deploy workloads or using blue-green deployments to container apps and GitHub Actions. We'll then finish off with a bit of Q&A. So if you do have any questions, please leave them to the end. If anyone online has questions as we go along, feel free to put them in the comments. And we'll just answer them on the way. Am I? That's awesome. So I'm going to stop. I'm such an amateur. What the hell? Okay, this is going to be fun. So screen 2. There you go. How's that? Awesome. Always good to get the teething problems about 5 minutes into the talk. That's okay. All right. So what are container apps? Kubernetes is hard, no matter how experienced you are at it. When I'm having talks with customers and developers about using Kubernetes, the one problem that they cite is kind of like a technical blocker to adopting Kubernetes is really the complexity, because it's not just packaging your applications into containers and deploying it to Kubernetes, it's administrating the cluster. And even though AKS is kind of like a managed Kubernetes service, there's still a lot of overhead that comes with working with Azure Kubernetes Service. So container apps is really built on the foundation of various open source technologies to deliver the same benefits of microservices that Kubernetes provides, but it's fully managed and it has kind of the serverless offering. They've recently come out with dedicated profiles, so there's like a mixture of serverless and dedicated workloads that you can deploy. But the kind of the short of it is it's here to kind of simplify Kubernetes. Behind the scenes, container apps will run on Azure Kubernetes Service, and there's great things, other great technologies like Kubernetes event-driven auto-scaling, Dapper and Envoy that are deeply integrated into container apps, but you're not exposed to this underlying infrastructure. So as a developer, all you really care about is, okay, here are my containerized workloads. I'm going to deploy them to a service in Azure. We'll deploy them to container apps, and Microsoft is going to handle all kind of the complexity of administrating Kubernetes clusters, Envoy, etc. For me, so I can just benefit from a platform. So like I said, it's kind of built, Container Apps is built on Azure Kubernetes Service, CADA, Dapper, and Envoy. And since it's kind of built on that, we just take advantages of those platforms without, of those technologies without having to worry about managing it. So this provides us service discovery for our microservices, fully managed ingress endpoints. We can take advantage of being able to kind of perform application lifecycle events such as such as upgrades, traffic shifting, and versioning in a much simpler way than what we would have to do if we were operating a Kubernetes cluster ourselves. So with this, we can build like various different types of applications, so microservices, APIs, event processing workloads, and background jobs using containers. If you're coming from an Azure Functions background, there's no real opinionated framework that you have to work with. Don't get me wrong, I love Functions. It has a great kind of integration story of other services in Azure and on-prem. But with Container Apps, the approach is if you can containerize your application, you can use Container Apps, which provides us with a lot more flexibility. One of the disadvantages is, or depending on how you feel about Windows containers, it may not be a disadvantage at all. It's limited to Linux-only containers. So there's no option at the moment, or if there ever will be, I'm not too sure, of deploying Windows containers to Container Apps. But if you containerize your applications and run them on Linux, Container Apps is the good place to go. And for those of you who have used Dapper, have many people used Dapper or not? A couple of you? Okay, it stands for Distributed Application Runtime. I've got a slide on it later, and it simplifies common tasks like event processing, pub sub, service invocation, and much more. And it also has this offering of robust kind of scaling. So underneath the hood, it uses Kubernetes event-driven auto-scaling. So rather than having to install that on your AKS cluster, it just comes, Container Apps comes with CADA out of the box. And that means we can scale on a variety of different event scale triggers that CADA provides. It also scales on CPU or memory or HTTP requests. And we can declaratively implement these scaling rules without having to manage the complex infrastructure. And then for the consumption-based workloads, we have the option of scaling to 0 and then only paying for what we use when we're actually using our Container Apps. So just some scenarios of what we can build with Container Apps. So again, it's kind of designed for that microservices architecture, just to try and simplify the hosting platform for it. We have the option to integrate with Dapper. So if you're not aware of Dapper or you don't want to use Dapper, you don't have to. It's just there for you if you're building applications using the Dapper framework. Today's demo, I'm going to be making use of the public API endpoints example. So a good example, we might have an API app where we're splitting HTTP requests between different revisions, and I'll go into a little bit what revisions are in a second. And we can actually scale determined on the number of concurrent HTTP requests that come into our Container App. We can also deploy web apps to it, event-driven processing applications. So say if we're reading messages from a queue, we can build Container Apps for that. And we can also do background processing, which is really good because I see a lot of people building background processes using Azure Functions. You can do that. I've never seen it work that well because functions aren't really designed for the kind of those long background processing tasks. That's something more of like where Container Apps can actually be a little bit more benefit of those kind of scenarios. Now, I won't go through all of this. I guess the great comparison of how does a Container Apps compare to Azure Kubernetes Service. I'm not here to kind of like tell you you should dump all your Kubernetes clusters behind and don't worry about it. Container Apps is going to be the be all and end all. The main focus or the main choice between these two technologies is really around flexibility versus productivity. The value proposition for Container Apps, if you love working with containers, but you hate managing the infrastructure of Kubernetes, hate administrating it, or if it's just a burden to your development teams, Container Apps is the way to go. But if you want a little bit more flexibility, so you want to kind of have that ability to administer clusters and have a little bit more extensibility, Kubernetes is going to be the better option for you. Cool, so let's dive a little bit deeper into the various different components of container apps, just so we can get a better idea of what container apps are. So individual container apps are deployed to a single container apps environment. Now, if you're coming from a Kubernetes perspective, this is similar to a namespace. Conceptually, it's similar to a namespace. And essentially, this environment acts as a secure boundary around a group of container apps. So container apps within the same environment are deployed essentially to the same virtual network, which is either managed by Microsoft or even managed by yourselves. If you have your own virtual network, you can actually integrate that into a, you can actually integrate your container apps environment into a virtual network. And you write logs to the same log analytics workspace. So when you kind of provision your container app environment, essentially at that time, a VNet will act as a boundary around it. You either have two options. You either just provision your environment, and then behind the scenes, a virtual network will be provisioned, but that's just managed by Microsoft, or you integrate it with your own virtual network. When you're working with container apps and environments, you might deploy the same container apps to the same environments if they have related services, if they need to communicate with each other within the context of that environment. Maybe they're communicating to each other via Dapper. Maybe they share the same configuration or the Dapper configuration, so you need to co-locate those applications within the same environment. Or if you just want to have them write to the same log analytics workspace, you can deploy them within the same environment. There may be situations where you don't want to deploy the same container apps to the same environment. Maybe you're working in multi-tenanted scenarios where you're provisioning environments per tenant. So you have a SaaS product, but you need to keep that kind of data, have that isolation at the data and networks area. So you'd probably provision an environment per customer. There are limits to how many environments you can provision within an Azure subscription, but these can be increased through some various support requests. And then kind of coming down into the container app. The container app is just essentially a single independent microservice that has its desired state configuration. So in the demo I'm going to show you later, this could be an API, it could be a web app. Those would be separate different container apps that you deploy to a container app environment. Now, as I mentioned earlier, this manages, the container apps will actually manage the details of Kubernetes and container orchestrations for you. And you can use any runtime, any development stack of your choice, as long as they support Linux-based containers. They can also be run from public or private registry. So I'm actually going to show you how you work with your own kind of Azure Container Registry to pull images and run them as container apps. You can also run them from public container registries as well. But container apps can't run privileged containers or processes that require kind of that root access. Make sure I've got everything there. Cool. Awesome. So let's kind of go into kind of the deployment one. So this talk really is focusing on deploying and developing container apps for deploying applications for container apps. So I want to touch on this idea of revisions. Now, in container apps, revisions are an immutable snapshot of a container app. We can either run it in what we call a single revision mode, which is kind of the default, and I'll explain what the difference is in a bit, or multiple revision mode. Revisions are really handy for when we want to kind of enable ingress into those container apps and make it accessible via HTTP. It's really often, we often see customers, and it's really useful for these kind of scenarios where we want to direct traffic from one snapshot of our application to another. So typical scenarios of this would include, say if we're running A/B testing, we want to expose maybe 20% of our traffic to a particular version of our app, so customers will be direct there. Or if we're running those blue-green deployments where we want to kind of expose it in production, but not have any traffic directed to it, we'll run some integration tests against it, and then provided those pass, we'll switch over and we'll allocate traffic to that particular revision. Now, depending on how revisions are created, Essentially, we have this kind of clash of concepts between revision scopes and application scope changes. So revision scope changes are changes that will generate or create a new revision for our container app. And this is any change of the template to our container app. So this will include if we change the suffix of a particular revision, we're essentially naming a new revision, so it'll get created. If we're changing the configuration or the image that the container uses, or we're defining new scale rules for a container, we'll create a new revision. There are also application scope changes, which is more changes to the container app infrastructure itself. So if we're adding new secrets, we're changing the revision mode, the ingress configuration, any data settings or any credentials for private container registries, those won't generate new revisions. Those are just changes we're making at the application level. And then there are two different modes for how we can run revisions. There's a single revision mode. So essentially when we deploy a new revision, that revision will only ever be active at one time. So when we deploy the latest version, that will replace the current active revision. And then there are multiple revisions where we can actually run multiple versions of our applications simultaneously. And they'll remain active until we actually deactivate them ourselves. Just to talk a little bit about replicas. So they are kind of the unit of scale in container apps. The default replica count being 0, it supports that kind of scale to 0 scenario. When you're running in multiple revision mode, it's important to keep in mind that each revision will have its own scale rules. So you could have 10 instances of a container app that's running revision 1, and then only 5 instances of container app 1 revision 2 running due to its own scale criteria. Hopefully I've kind of illustrated that picture effectively. It certainly made sense when I wrote these slides. But the important takeaway is that different revisions will have different scale rules. I won't go too deep into kind of the networking architecture, but there's two concepts to keep in mind with networking, particularly around the environment level, because like I mentioned, the kind of the boundary around the environment is a virtual network, whether that's managed by Microsoft or yourself. So external environments, when we create an external environment, we're essentially enabling our container apps to be available for public requests. So these environments will be deployed with a virtual IP on a public external IP address. We can also have internal environments as well. So we can essentially say this container app environment is not going to have a public endpoint. It'll be deployed with a virtual IP that's mapped to an internal IP address, and that internal endpoint is essentially an internal load balancer. And then IP addresses will be issued from the custom VNets that we've deployed from a list of private IPs. And then when we think about revisions, we can say, okay, or container apps and using revisions for that, we can essentially say, okay, this container app is not going to accept any public ingress or any public traffic. And if it is, we can then allocate different traffic, different percentages of traffic to particular revisions as well. And I've kind of touched on bringing your own virtual network, but with container apps with the ability to kind of bring in your own virtual network, you can deploy an environment that's using that custom virtual network, and you can have that optionally without the public IP address, so you can really lock it down for those kind of use cases where you do need to lock down your container app environments. A little bit about logging. So containers will write logs to standard output or standard error streams, which you can surface through log analytics. There's various amounts of logging options available using log analytics, so you can emit logs from your application, from your container applications, and you can also emit logs from the container apps resource themselves. This is all, you can query that within log analytics workspaces. Support for Azure Monitor is currently in preview, so if any of you in the room are kind of emitting logs, storing them in a storage account, or you're streaming them to Event Hub, you might hook that up with a partner solution. That is in preview, but kind of the generally available and supported way of doing it is through log analytics at the moment. Again, I don't have timelines on when it'll be available through Azure Monitor, unfortunately. And then to talk a little bit about CADA, so when it comes to scaling, It uses Kubernetes event-driven auto-scaling. So there's a whole bunch of scalars that Kata provides, and we can actually define those scaling rules within our container apps, so that it could be HTTP requests, it could be messages coming into a queue. Provided that it meets the criteria of our scaling rules, our container app will scale accordingly. And here's some examples. So we've got HTTP requests here. There's support for kind of MySQL events coming in, Redis streams, Event Hub, Service Bus, Azure Queue, and we can also scale on CPU and memory as well. And then just to talk a little bit about Dapper. So Dapper, the Distributed Application Runtime, is really a framework that helps us build event-driven, resilient distributed applications. So these can be, just taking container apps away for a second, these can be on-prem, in the cloud, or edge devices. It essentially provides a set of APIs that makes it easy for us to write distributed applications. So it'll have a sidecar process next to your application. This can be hosted on Kubernetes, container apps, or any other environments. And it will give us kind of primitive forms and APIs to work with pub sub capabilities, state management, service-to-service invocation, etc. And you can communicate with HTTP or gRPC. And it's also, there's a whole bunch of languages and REST APIs as well. So there's SDKs for C#, Node, Go, Python. I think they're working on a Rust one. Not too sure. It's still ongoing, but it's also exposable through HTTP or REST APIs, sorry. Cool, that was a lot of slides and a lot of talking. So we're gonna jump into the demo, which is going to work. So essentially I've got a web application that's gonna talk to two different APIs. And I'm gonna use GitHub Actions to kind of build my container image, and we're gonna deploy that to a blue slot. When we deploy it to this blue slot, there's gonna be no traffic directed to the blue slot. It's gonna be publicly available, so we're gonna run integration tests against that slot. Provided they pass, we're gonna swap the traffic and promote that revision that sits in the blue slot and promote it to the green slot. Now, for those of you that are coming from kind of like an app service environment, it works a little differently because there's the idea of deployment slots in app service. This is not really the same. It's more, these are just revisions that are existing. We're just gonna be manipulating the traffic a little bit. So hopefully everyone can still see that. How are we doing on the stream? See that screen? Awesome, cool. So if I open up Visual Studio Code, no, we can't? Awesome. Okay. So if I scroll down, is it scrolling down? No, it's not. Apologies. Stop screen. Share screen. That's right. We're going to get that awful there. There we go. Is that better? Scrolling down? Fantastic. Cool. So here I've got kind of my three different APIs. And what I'll do, I'll actually show you. So I've got a simple Blazor application that's listening to two different APIs. And it's deployed in UK South. I usually deploy to Australia East because that's the closest data center to me. But essentially, this is going to just display some products in a hypothetical store that I've got. And to show you kind of like the underlining API, here it's just giving me product ID, product name, and then there's this manufacturer field that I've set to blank. So showing on my web app, there's no fields here, which is not very good. So I want that to be a little bit more descriptive. So if I go into Visual Studio Code, what I've got, I'll go into my kind of program CS file. Here I'm just using bogus to admit some fake products. And here on line 23, I kind of change that to actually fill that value for manufacturer. So in order to do that, what I'm going to do, I'm just going to go into actions. I'm just going to kick off this, run this workflow. I have to come back a couple of times, but that's okay. I will show you the GitHub action file here. So here, I'm just going to get rid of all of these, not now, go away. Awesome. So in this GitHub action workflow file, I'm running kind of two deployments side by side. So first I'm going to deploy my infrastructure. So within this infrastructure project, I've got this main.bicep file that's kind of defining my container app, was declaring my container app resource. So here on line 44, I'm saying, okay, this container app is going to have multiple revisions, which is going to enable that blue-green deployment scenario and allow me to switch ingress between one revision and another. Here, I'm saying in my ingress block, we're going to expose that to the public internet. So it's going to expose, public traffic will be able to communicate with this application. We've got this on target port 80. And essentially, that's going to kind of use a container image for this particular container app. So if I go back into my GitHub action workflow, I'm building or deploying that bicep template. I'm retrieving the existing image that's already been deployed to that container app environment, so that kind of version that's not showing any information about manufacturing or who's manufactured that particular product. I'm going to grab that image. I'm just going to preview my bicep, make sure it's all good, and then deploy it. And then once I deploy it, once I have kind of deployed my infrastructure, I'm then going to start the process of building my new container image. So that's going to grab the credentials for my container registry. It's going to build, do a Docker build and push that image to that container registry. And then here we're going to deploy it to the blue slot. So let me get some more real estate. Essentially, I'm going to get the current revision name, which is essentially going to get the URL of the current revision. And then I'm going to create a copy. So here I'm using an inline script to use AZ container app. I'm copying the revision of my current revision. But for the image, I'm going to use the image that I've built previously. And then on the next line, I'm going to set that traffic for that copy to 100. Oh, sorry, so it's going to use my current image and set it to 100. So that's going to be my green slot. Oh, my blue slot, sorry. Once I've gotten that blue slot, once that revision's been created, I'm going to get that URL, and then I'm going to pass it as an environment variable to my integration tests. There's nothing too fancy I'm doing in my integration tests here. All I'm really doing, if I just go into that integration test, I'm essentially saying, okay, I'm going to make a response to that URL, and it's going to, if it throws 200, returns 200, great, the integration test is passed. That's going to be all cool. So once that integration test is passed, we're essentially saying, okay, let's get that current slot and then promote it to a blue slot by essentially getting the blue slot URL and setting that traffic to 100. So if I go back into GitHub Actions, it's waiting for me to validate that infrastructure deployment. So that's going to kick off. How am I doing for time? Just aware of that. All good? Awesome. Fantastic. It's fine? Are you just making me stall? So all good. Just kind of wave your hand saying, Will, come on, hurry up. We've got to go. No, it's all good. So that's going to deploy my template. So essentially, what I will do, if I go into Azure, if it lets me, fantastic. What I will show, if I go back into this resource group, I'm going to go into this product API. The view kind of GUI. We can avoid it from the, I'm more of a kind of like command line and do kind of proper way, inverted commas, or how we would do in business environments, or in the real world, sorry. So if I go into revision management, I should see, and I will scroll a little bit. Essentially, that's all provisioning. It is all working, but if I click on that, each revision will have its own particular URL. So here I've got that revision, and you can see that it's usually like the name of the container app itself, plus this little suffix here that we can find here. So this, the name of that revision will form a specific URL for that particular revision, and that's what we're going to be using for our integration tests. So if I go there, that's going to build, take its sweet time, obviously. So everything's still working there. So hopefully, give or take, so there's my API project that it's built. It's going to build the container image. Who here has actually been using GitHub Actions this week? I've spoken to a couple. It's been an interesting week. Yeah, like at the same time every day around 1:30 in the afternoon, there's been an issue. So I had kind of the GitHub status.com website open earlier and thought, you know, if it's all green now, it's going to be all green in an hour. And it's going to be fine today because no one deploys on a Friday. Why would you? No one ever deploys on a Friday. Running right now. Oh, awesome. Okay. That's good to know. Who knows? This might fail. That is GitHub Actions. That's what happens when you say, okay, you handle this infrastructure for me, and I won't care about it. Oh, it's not working. Now I do care. Yes, yes, it is. What I will do, instead of making you guys watch all of this, I will show you one that kind of worked earlier. So yeah, this was my GitHub Actions adventure over the past week. It was fun, lots of red. We always like to see that. So I'll actually duplicate that. So in this deploy to blue slot, there's the high level. So we're getting this URL for that particular blue slot, and then we're going to pass it through. So it's going to look something similar to this. And we're going to use that for our integration tests. So if I go back into the one that we're running right now, there we go. So it's deploying to blue. So here I'm just setting up the .NET environment. I'm using .NET 6 for this. I can run it on .NET 7 as well. I just chose .NET 6 because I've done this presentation or a version of this presentation a couple of times. So here I'm going to get the current revision name. I'm going to make sure that we're going to create a copy of that. We're going to get the current revision name, make sure the traffic of that is allocated to 100%. Then we're going to create, with the new copy, we're going to deploy our container image to the blue slot, set ingress to that particular revision to 0, so we can run our integration tests on that blue slot. How long did that take last time? It took 8 seconds last time. Oh no, 1 minute, 7 seconds. So hopefully we'll be able to get the blue slot fairly quickly, provided that succeeded. It looks like it's happy with that. And then what I'm going to do, I'm going to show you kind of the JSON response from that blue slot URL, and that's what we're going to be running the tests against. I've got 2 more minutes. Do you hear that, GitHub? You got 2 more minutes. So I don't have to do the whole Blue Peter thing. Here's one I showed earlier and say, it works, it totally works. Okay, cool. So there's my blue slot URL. So what I'm going to do, I'm just going to open up tests, copy and paste on a trackpad. It's always fun. I'm going to hit that endpoint. And you can see now there's actually more information for that manufacturer field. So that looks good. The integration tests are passed. I've put in a deployment gate just to try and emulate what we do in a kind of like the real world. We want to put some kind of manual controls in place. Say if we have to control our deployments, say we've got to answer to a control, a CAB board or a control change board. These are the kind of controls that you'd implement in place. And that's going to deploy that to that green slot. So this kind of API will now be, we're going to allocate 100% traffic to that. I've actually hit that URL itself since it's publicly available. I can just go ahead and do that. But now we're actually going to switch 100% of our traffic to that particular slot. So if I look at that, how long did it take last time? Didn't take too long. You might just do it in time. Who knows? It's going to promote to kind of the blue to the green slot now. So it's very different from an app service or a function environment perspective. So one of the great things about Azure Functions and App Service, we have the ability to kind of swap deployment slots, and it's kind of almost instantaneous. The disadvantage here is we're only really setting ingress to a particular revision, so it's kind of that extra step. Within that command, which is like AZ container app ingress, there's no way to specify which image you're wanting to set ingress to. You're setting it to a particular revision. So it's not, you've got to create a copy of the revision and deploy your new image to that revision, then you've got to set ingress. So it's not perfect, but it is a way of how we can actually do it. Cool, so that has passed. So hopefully when I hit my web app, might be a little bit delayed, but hopefully, okay, hasn't come yet. It might take a wee while, so you'll have to trust me on this, which is not great. But as we can see now, this is now, there's no revision suffix here. So this is the revision that's receiving 100% of the traffic. So no matter how many times I hit that, we can see that the manufacturer information is coming up. So now that field is pre-populated. So maybe in like 5 minutes, once I've actually finished that talk, it will all show up. Awesome. So very quick recap. Container apps is great because it's essentially Kubernetes without the Kubernetes. You get to enjoy the benefits of Kubernetes without having to worry about managing your clusters. Hopefully this is giving you kind of like an illustration of how we can use revisions to manage the lifecycle of our application, how we can open up some really cool deployment scenarios such as blue-green testing. There's also A/B testing as well that we can implement, which is quite cool. There's built-in observability, built-in integration with Dapper, CADA, so essentially all of those kind of good parts of the cloud-native ecosystem are kind of there available to you. You do sacrifice a little bit of flexibility that you would use using Kubernetes, but if you don't want to manage that and don't want to worry about it, this is kind of the answer to that. Awesome. Thanks for listening. Hopefully you had fun. If you had any questions, feel free to stick your hand up or come and chat to me afterwards. And sweet. Thanks, everyone.
Thank you, Will. It was a really great session. Container apps certainly looks very, very interesting. We'll be back in a very short minute with Rachel Breeze, who's going to be talking about accessibility and doing lots of DevOpsy things with accessibility. So yeah, let's give Will another round of applause, and we'll bring Rachel up onto the stage. Rachel. Okay, and we're back. This time with Rachel Breeze, who will be talking about building and deploying accessible sites. Rachel, over to you.
Hello, thank you all for coming. In this session, I'm going to share my journey with adding accessibility checking into the Azure DevOps pipeline. Before we start, a little bit about me. I'm a senior developer and technical squad lead at Nexa Digital. I am a C# developer. I'm not a front-end developer, but hopefully you'll see through this slide deck that everyone is responsible for making accessible websites and applications. Nexa Digital, who I work for, are a human-centered research and design and development company based in Macclesfield, and we've got an office in Cambridge as well. We're 110 people in the UK, and we're owned by Nexa, which employs about 2,500 people worldwide. I'm an Umbraco MVP. For those who don't know, Umbraco is a content management system, and it provides a framework for building websites and web applications. It abstracts the content management away from developers, allowing us to do what we do best, build websites and applications. Umbraco is open source and utilizes the Microsoft technology stack. I'm also part of the Umbraco community accessibility team. We've got Umbrad coming up next week. I'll share a URL at the end. That's all for Global Accessibility Awareness Day. But today I'm going to talk about why accessibility matters, accessibility in the development life cycle, how we can add it into the Azure DevOps pipeline, Azure DevOps accessibility test planning, as your approach will differ depending whether you're on a greenfield or a brownfield site. First off, to get people to add accessibility into the DevOps pipeline and get approval from management, we need to tell people why accessibility matters. So there's loads of laws that cover it worldwide, and that's always a good legal case for getting it added in. I've pulled out a few. These aren't all of them. But if we develop our websites and applications to level 2, WCAG 2.1 level AA criteria, you should comply with most of these laws. There's also a business case for it. Globally, there's a number of people with disabilities is over 1 billion, with a spending power of more than 6 million. In the UK, 14.6 million people have a disability. That's roughly 22% of the population. According to Optimax, 22% of the UK population have brown eyes. Imagine excluding people who have brown eyes from using your websites and applications. It's a big thought. Accessibility helps improve the usability for everyone. It helps SEO. You've built your website, you've invested time, money, and everything in the service. You want it to have the widest reach. But for me, this is why I advocate for accessibility. This video sums up exactly why we should be doing it. So there's a lot more to that. I will share the full text, full link at the end. So earlier you heard me talk about Web Content Accessibility Guidelines, or WCAG. These have 4 rules behind them, and they're designed to give guidance as to how website and content should work for people with different abilities. I'm just going to go over the bullet points really quickly. Perceivable means information and user interface components must be presented in a way that people can perceive content. For example, we provide alternative text for images. This allows them to be read in other forms like large print, braille, speech, And even when we have a slow internet connection, we see the text before we see the image. For operable, this means making all functionality available from a keyboard and as many alternative inputs as possible. We should also help users navigate and find content by providing consistent navigation and consistent identification of elements. Understandable means making the text readable and understandable. Text should have a reading age level of lower secondary education level. In the UK, I think that's year 9. It's also about users finding and correcting mistakes easily. And finally, robust. This means that when we write the HTML, it validates against the schema we specified. And it also means if we display status messages, then assistive technology gets the notification without having to focus on those status messages. There are 3 levels of accessibility. A, which is the minimum level. Without addressing these items, barriers exist that cannot be overcome by assistive technology. AA, this is more accessible, and the criteria at this level establishes a level of accessibility which should work with most assistive technology. And AAA, which is even more accessible. Some AAA criteria can't be met everywhere, so we recommend meeting it where you can. And if you say your site is AA compliant, it means that your site has met compliance of every one of the criteria at AA and every one of the criteria at A. We know that when we don't design for people with different impairments by accident or by design, we're excluding them from using our products and services. And as Kate Holmes says, exclusion isn't a PR-friendly word, but it is a universal experience. We all know what it feels like when we're left out. And as you saw from the video at the start, how important it is to make sure everyone joins us in the world of technology. So accessibility in the development lifecycle, it doesn't just start at DevOps. It doesn't just start when we go into accessible development. Into development. It starts before. We all work with designers and user researchers in our communities. Derek Featherstone's done a whole series of tweets a couple of years ago about how we can build accessible technology from our prototypes. He talks about using voice recognition to ask people how they might accomplish a task. Talk to people about who use voice recognition software and ask them how they'll accomplish a task. Share your prototype with people who have low vision to see if they've got the right contrast, and so on. It's a great series of tweets. Again, I'll tweet the link to them at the end. So we've gone through the design and research phase. When then we go into development, there are tools we can use in the development cycle to help us. In Visual Code, there's an accessibility linter plugin, extension, sorry, that we can use. This, hopefully you can see that. Oh, is that on the? So this, as you can see along the top, it's got a red tab that's open that shows all the errors. So there's loads of errors on that screen. It says there's more than 9 on that left at the top. And at the bottom, there is a list you can pull up, and it pulls up all the errors on, that are in that HTML. And it says there's 19. Hopefully you can see the 19 here. And if we start to fix them, just like it would in wrong keyboard. That was the one with the T on. You can see as I fix it, it's now gone to 18. So you can fix your errors and find your errors with Visual Code with this extension as you go along. If you use Visual Studio, I failed to get this open. Let me just take that out so you don't see the client names. If I failed to set that up, just 2 ticks. That's going to stream. So in Visual Studio Code, there's an accessibility linter in there as well. Can't share that, sorry. 2 ticks. Right, there we go. So in Visual Studio, if you have a HTML file open, you've got the Yes, I was like, Callum, stop the stream, but it's okay. So just while this loads up, this has got a accessibility checker in it for HTML. You can also use an accessibility checker tool for WPF, sorry, and all the other tools that are available. I don't work with them, as you can tell, and I can't remember the acronyms. I'm a web developer. So for HTML, you can tick on tools and click on check accessibility. It'll pull up this checkbox and click validate, and it'll give you the errors to fix, and you can go away and fix them. The list of errors here is different to the list in Visual Code. I would start in Visual Code before going to this. And then most of us work with dynamic sites, so run that. And we have this website that I've pulled from Washington University's Accessible University demonstration. But what I want to show you in here is what Microsoft offers in terms of auditing. We've got Accessibility Insights for Web. It's got a great 3-minute video that you can add to it to introduce it. There's this fast pass routine, and it highlights the errors on the page. And if you expand the errors, it will show you the reasons why that's errored. It's always important. All reports should contain details of why something is errored. And it tells you where it's errored, and you can see it highlighted on the red. But what's also good is if you use Azure DevOps and you've linked it to your Azure DevOps account by clicking on the settings, you can then click File Issue. And this was slow this morning, so fingers crossed. So it'll load up your DevOps board, and you can create a task straight off the back of there, link in with the issues and why it's failed. So your QA team or yourself don't have to spend a long time writing up a ticket, which I think is really cool. Makes you more productive on the manual testing, so that's really helpful. If you haven't got access to that, there are other tools that we do use. We have Axe DevTools, which is an extension in the developer tools in Chrome. And everyone's probably familiar with Check-in Lighthouse as well. So where you run it and you click Analyze Page State, and it'll do the performance, the best practice, and SEO if you check all those and produce a report. So those are some accessibility things we can all do as developers before it goes into DevOps. And then we also have DevOps itself. I've loaded a slide to come back out. I just really so there's an accessibility checker in Azure DevOps. So if you go into there, all my demos are going to be through the GUI. I know there's a YAML version, but I think the GUI is more helpful in explaining what we're trying to achieve. So what I've done for this is I've got an accessibility checker pipeline. Show you how to set that up. So you add a task in for it, click your plus sign, search for accessibility checker 1 and 1.8, click add, and then put your page URL in that you want to test. This is a default example from DQ, and then you set up the test title. That's important because it'll show in your test plans and the tests that you want to run. You can also do it on specific areas of the site, say in HTML to include and exclude. As you've probably noticed, the one flaw in this test, if I go back to it on here, is even if it fails, it doesn't report a failure. But what it does do is if I go into that release, is it'll tell you why report areas that have failed, and it shows you on the tests where it's failed. And again, you can click on a failure and turn it into a bug, create a bug for your Azure DevOps pipeline there. And it's in the test plans too. So you can manage all your results through the test plans, through the runs, and you'll see it in in there. So it's this Mars demo. So you've got your test plans that just get pushed up straight to there from that one. The next off-the-shelf, so to speak, extension that's available in Azure DevOps is Google Lighthouse Scan. Now, there are 3 versions of this. The easiest one to configure and the one that we can use is the one with the square on it, and I'll show you what I mean by that. So if I search for Lighthouse, you see it's returning 3. The one that I'm going to demo is the one with the square around it that says display Google Lighthouse reports and evaluate audit scores with assertions. And the reason I like this one is it's got some really great documentation. So all these little eyes will show you what you can do. And if the assertions gives you a list of options, links off to the GitHub repo, and you can see everything you can set. So you can even check if you've got HTTPS enabled on your site, which, you know, people might fail on that. So there's lots of nice tests in there. This takes a while to fire up again. So I'll just show you a test that's run previously. These fail. When they fail, you get a proper failure. And it'll return why it's failed. And the other thing this one does is, this Lighthouse test does, is it puts a Lighthouse tab at the top. This is using Lighthouse CI, which is has a command line interface for it. It pushes the results out to a temporary place and pulls them back in, and sometimes this bit's a little bit flaky, as you can see. But the nice bit about this is that you can push it into the Lighthouse CI server, which you can hold in-house, and that makes it less flaky, and you've got a historic run of all your Lighthouse tests then as well. It's one thing I need to check out a bit more. And then the final thing we can do with Azure DevOps is our own automated testing. And this is the bit that I really like. So to show the automated testing, what I've done is I've created a static site. It's got a sitemap. It's got a home page. It's got a colour alone page pulled from the UK government website, and the Accessible University page that we looked at from Washington before. And what I've done is write some tests in the Cypress. Like your boss watching you when there's a bug, having everyone watch you do a demo. So while that's opening, I will just show you the tests. The first test we're going to run is one that just goes off to the URL and validates the HTML. And that is for the testing the standard that the HTML is robust. So you remember the poor things we looked at the start. This is a HTML must validate, so this allows us to do that. And that'll pick up more than accessibility testing. This particular test will check things like your JavaScript includes and things as well. So it's a nice test to have. And then the next one we're going to do is visit the URL, inject Axe, which is the accessibility testing tool, and get the results back. And I just wanted to show that all the tests up to now have been single URL tests, but you can set it up to do the sitemap or a preset array. So hopefully that has loaded. It's loading. And you don't have to use Cypress. It's just the tool I've picked for this demo. And I'll talk more about picking a tool in a minute. Or whilst that loads, let's do that whilst that loads. So go back into get the right window. Here we go. So for picking a tool, there's a few things, because you want the tool to work with Azure DevOps as well as for your developers. So you want one that's got a GUI. Lots of people like working with a GUI locally. You want a command line interface so you can run it through Azure DevOps. You want a reporter. You want it to support a reporter that's supported by Azure DevOps. So JUnit, NUnit, XUnit, and so on. And you want to use one that's been developed by an ACT accredited vendor. And the reason you want to do that is because ACT stands for Accessibility Conformance Testing, and they've got a rules format, which is a standard that describes how to write high-quality automated rules and manual testing rules as well. And it's the standard that's used by Axe, which we've seen demoed already. So Axe is for Lighthouse. It's used by DQ, and things like that. So you want one that's recognized so that you can say back to your clients, we've used a recognized, accredited tool. And just like you would for if you're doing your website, you write your scripts, then your development team can use them when they're doing the builds locally. You commit the scripts to source control, you build your Azure DevOps pipeline, publish the results to Azure DevOps test plan, and then, most importantly, you manage the findings from the results. You don't just say, yeah, we ran a test against it. You want to get the output and use those. So Cypress is loaded locally. I'm using the end-to-end option in this. And those 3 tests we looked at the start, just run them quickly. Doesn't matter if they pass or fail at this point. It's just making sure that they actually run. So our HTML validate, it's gone off. Cypress records where it's going to, so you get your GUI, and with Cypress you can click through. There are other options available. Yeah, demo gods love me today. Right, this isn't the important bit of the talk. I just wanted to show that they worked. So I'm going to move into how you put that your automated front-end testing into Azure DevOps. So on the front end, we build it like you would normally. So if I go into this and click Edit, we pull. Can you see that? Do you want me to zoom in a bit? You're a little bit. Yeah, is that better? Oh, yeah. Brilliant. Okay, so as before, you pull in, as any build in there, you pull in from your sources directory. I haven't included the root folder when I pull that in. You might have seen when you've downloaded a zip file /s and then the rest of your folder. When you've downloaded the build, that just means this build will replicate exactly, if I set that to false, it replicates exactly what I've committed. So the package is JSON. With it set to false, packages JSONs at the root, and because it's NPM, that's where we want the packages JSON to be. I've archived the file as a zip, replace any existing archive, and publish it as an artifact. So it's a simple pipeline for doing the build. Then the releases pipeline, so edit that. The artifact is from the build that we've just done. We extract the files straight into the root. I'm not overwriting, cleaning the destination folder because I'm going into the same place as the working directory. If I clean it, I'm going to delete my zip before I've worked with it. Install npm at the command line. Because packages JSONs at the command line, this will just run. I've committed my tests, and I'm going to run them using the command line, and I'm pushing the results of the tests into JUnit. The other thing to know is in the control options, I've got continue on error enabled. And the reason for that is if it didn't continue on error because it found an issue in the testing, it would just stop. And we wouldn't capture why it's found the issue in the Cypress test results. So putting continue on error means it will run through to the Cypress test results, to the publish test results task, which then means we can publish them up and get a record of the errors. So as I mentioned earlier, if we use a reporter that's got a recognized result format, it's dead easy to push it across. So we want to make our lives easy, don't we, as developers? So yeah, and then when I run that, if it fails, get an orange, because that's a complete failure. The first one failed for proper reasons, like I didn't set it up properly, but release 2, that's a proper failure, and it's orange because it's failed, but we did fail on continue. So we know we've got to go in and look at things. So click on the issues. It reports how many issues have been found in there. We can click through to look at the issues, get the reports, and as before, we can create a bug for them. So that's automated testing with Azure DevOps, but accessibility isn't just about automated testing. It's about manual testing as well, and I want to show why before I show how Azure DevOps supports that. So one of the tests that we ran was on explicitly on this page, which talks about accessibility and contrast. And the errors that have come back that we can fix are related to landmarks and nodes. They're not related to the colors on the page. And we can go to that page and there are no contrast issues if we check it directly. So if we go to this page and run the contrast checker, WCAG contrast checker, there's no issues with contrast. So can anyone look at this page and tell me what the issue is? Why am I going to fail this page? Okay, you're either know it all and you're just too polite to say. So I'm just gonna go. The issue is that the top and the bottom mushrooms are dangerous. The only way you know they're dangerous is because the content's in red. And the middle mushrooms are okay to eat, and the only way you know they're okay to eat is because they're in green. And that's fine if you haven't got color blindness. But I'm going to show you what happens if you've got a red color blindness now. So this is a simulator. It doesn't represent totally how people experience each of the issues that are listed on the simulator, but it's a representation of how someone might see it. So I've put the color blindness filter on, and 100 people, 1 in 100 people don't see red. So I've put that filter on. The top and the bottom mushrooms, which are not good to eat because they're going to kill you, are in green, okay? And that is why we shouldn't just use, well, it's not one of the reasons, but this is a good reason why we shouldn't just use color to convey meaning. Another reason is in the UK and Western societies, red is danger. In China and Eastern countries, it's good fortune. So we need to say, explain what we're trying to say, not just use color. So I'm going to fail this because whoever's written the content hasn't made it accessible. So we've got an Azure DevOps plugin that you can use to capture a browser details. So I capture the browser details, and you can put notes on there. Click Save Content. I'm going to raise a bug now and say color used to convey content. And you'll notice on this, there's an image action log we can include, and we can also include the page load data. So hopefully this is going to work. It doesn't always work for me because I use 2 DevOps repos. I go back into DevOps now and go to the Wikipedia, the work items. The one that I've just created has, no, should have, I knew it wasn't because it's a demo. I've got one I prepared earlier. It's got you see it's got the image on it of the page issue, and this is the bit that excites me for QAs, is because we click the include page load data in it. Can you see that? You're right. Do you want me to zoom in again? Because it's got the page load data on it, I know everything about what you were doing when you saw that page. As a QA, I haven't got to go, I was on Google Chrome, I was on Windows, I was on a Mac. I've captured everything that developers are going to go back to you and go, why did you fail that? So I think that's a really handy plugin to use as well. I'm up for less writing. Yes, Richard? It was called the, got a screenshot of it on here. It's okay, no, it's fine. It's called Good call to coming back to the slideshow anyway. It's okay. It's called the Test and Feedback plugin, and it is from Microsoft, and it's an extension for Chrome. Yeah. So as you've seen, it's not manual or automated testing. It's automated testing and manual testing. None of the automated tools we've looked at are a replacement for manual testing. And only when those tools are passed, only when the automated tools are passed, should manual testing start. Otherwise, your QA team or whoever's doing the testing is just going to be finding the issues your automated tester can find. And we're also testing for usability. We're not just testing for compliance when we do the manual testing. So I'm going to talk a bit about DevOps accessibility test planning. And the reason I want to talk about that is if you throw a brownfield site at a sitemap, you're going to find loads of errors. So let's start from the best scenario. We talked at the start about planning for accessibility from the design and the user research. A good next step is to use a design system like Storybook to add accessibility testing for your web components at that level. Then when you move into Visual Code, Visual Studio, you test your accessibility. As you go along, use tools like Accessibility Insights, Lighthouse, and AxDev tools to test. Write and use, that's the important bit, your automated test tools in the development cycle. Then implement an Azure DevOps pipeline to test and review your results. When you're reviewing your results at that time, because you've followed all the other steps, there shouldn't be, fingers crossed, ideal world scenario, there shouldn't be too many fixes in the Azure DevOps pipeline. So the review results should be fairly simple process because you've caught everything before you've gone into the DevOps pipeline. And then once they've all passed, your manual tester can start. Brownfield's a bit messier. If you've inherited a site or you're just putting accessibility testing process into an existing site, the first thing you need to do is audit the site to find the issues. So only when you know what the issues are, can you prioritize them? And each priority will be based on what that website does. So it's very individual to the websites. What you want to do is as you fix issues, you need to put bits of testing in for the fixes to make sure you never introduce a regression. And then for new functionality, put accessibility testing into the start. So brownfield's a lot harder. And then just onto the summary. So when we design and build for accessibility from the start, remember not everyone accessing your Apple site uses a mouse. Not everyone sees content the way you do. Not everyone thinks the way we do. Automated accessibility testing helps as a support for accessibility testing, but it's not a replacement for. Never forget, accessibility supports social inclusion for people with disabilities. It can help improve the usability for everyone. And developed the right way, the internet provides equality of opportunity and social inclusion for everyone. If you want to learn more about accessibility, next week, May the 18th, is Global Accessibility Awareness Day. There's loads of talks around the world on it. The Umbraco community, we're running Umbrad. We've got talks on adding accessibility into your user acceptance criteria, as well as accessibility in Umbraco. But yes, thank you. Any questions? Thank you all.
Fantastic. Thank you so much, Rachel. Incredibly insightful talk. I'm just checking if we have any questions in the chat. No, we don't. But if you do, of course, Rachel will be around today. You can... Oh, Will has a question. Here we go.
Awesome talk. So for kind of accessibility for the back end, are there any tools that you see, because obviously a lot of developers might have their own accessibility issues. Are there any prominent tools that kind of help on the back end? So C# code or anything like that?
So yeah, that's another talk I give actually about accessibility for developers. So coding standards are a big help. So that we need to talk to our team to see what they need for support. So uppercase, for example, doesn't work for people with dyslexia. I know it's the standard for constants, but people with dyslexia need to see the shape of the word to understand a word. So, and caps locks gets rid of that. So that's one thing we can do. We always have the tabs v spaces debate. There is, if we use spaces, which I've seen people advocate for still, screen readers read space, 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 space. Braille users feel space, 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 and you reduce, Braille users have only got 80 characters on their screen per row. So if you have a lot of indentations in your code, space, 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 say you've got an indentation of 4 if statements, their first 16 characters they feel are space, space, space for 16 times. Whereas if you use tabs, they feel 4 tabs on their keyboard, and then they're straight into the code. So there are things around that. The Microsoft Visual Studio Code's got lots of support in the back end as well for different accessibility settings. So for people who've got who don't feel light on their eyes, they don't like it, they're photosensitive. Whyte doesn't work for them. And obviously you can have bigger text and stuff as well. So there's lots of settings, yes. Yeah.
We'll take the 2 questions that are up, and then we've got the next talk.
Hi, thank you, Rachel. Really, really brilliant. Thank you so much. So following on from that, where do you feel is the most comprehensive list of the sort of things that you just said? You know, sort of like the guide for tabs versus spaces, white colorings. Where do you feel that a good place to start from for people who haven't really considered that for us?
I haven't seen a good place on that. That's a good point. I haven't seen it at all. Sorry.
Fantastic. And just one last question from way over here.
Oh. I was very nice talk, by the way. Excellent.
Thank you.
I want to ask you something. Let's say if you would take a team of developers, right? Do you think that developers, they can be quite sometimes doing the development hesitant or to ask about accessibility, or maybe it's a culture sort of that needs to be addressed or changed in the development community? Actually, what do you say?
I think you're right. Accessibility does take a backseat over performance, say, but performance, I would argue, is part of accessibility. A slow site is an unusable site, and accessibility is part of usability. We need to explain the reason for creating accessible sites, like I did at the start, to get buy-in from everyone. If you don't get buy-in, you won't get your development team to do it, or even if you get your development team to do it, your board need to back you because there's some processes that you need to invest in, right? So it's about getting buy-in. Yeah, have I answered your question? Yeah, thank you. Sorry? Yeah.
Fantastic. Well, clearly a lot of interest in the room for everything Rachel had to say. Let's give Rachel a quick round of applause. And coming up next, we have a talk from Mert about using Azure Chaos Studio to build some resilience into our applications. Give us 2 minutes and we'll be back with him. Okay, we're back. And we're back with Mert, who's going to be talking a little bit about Azure Chaos Studio, something I'm really excited about. I've not seen too much about this topic, and it's definitely something that's new and hot in the Azure space. So, Mert, over to you.
Okay. Hello, everyone, and welcome to Microsoft Factory London and Global Azure. And my name is Mert Yeter, and today I am going to talk about the Azure Chaos Studio. So before start, I'd like to introduce myself. I am working as a cloud solutions architect, and I live in Istanbul, Turkey. I was going to say I came here for a long way, but New Zealand that's not fair. Okay, and I think that is what global Azure means. So I'm a Microsoft Azure MVP for 2 years, and I am trying to a regular contributor to all communities around the world. And you can see the Cloud Family, Azure Live, and the MS Auto. It is the biggest community in Turkey, and I am one of the community leads of MS Auto. You can reach me out from social media. And last thing, I am also recognized as traffic ambassador for my contributions to open source community. So I don't like to start with questions. This is just a slide, but I'm going to ask a question for you. I think all of you know what BCDR stands for. So who have any disaster recovery scenarios? Don't be shy, come on. No one? Okay, this is brave. Okay, I have a disaster recovery scenario, but I am going to ask another question, but you don't have any disaster recovery scenarios. I was going to ask, have you ever tested your disaster recovery scenario? Because we are always telling lies to ourselves, like, my infrastructure is perfect. We don't need any disaster recovery. Or my disaster recovery scenario is better than perfect because I don't need it. We are using cloud. We have SLA. We don't need anything. Cloud covers everything. But, you know, we have experienced a pandemic in the century. So everything is possible. For example, one day your phone is ringing and your manager is calling, say, hey, your perfect architecture is not working. Okay, I know, because an asteroid hit the data center and I don't have any replication, so it is not working, it is not normal. And more realistic example, any Star Trek fans here? No Star Trek? Okay, I'll pass that one. And a realistic one, do you remember the date, March 2021? The Azure AD outage. Yeah. If you have an application integrated with Azure AD, you cannot forget that because it was for 14 hours and you cannot do anything about it. And what I'm trying to say is some outages or some problems you cannot imagine what will happen. So that is chaos engineering. Chaos engineering is a methodology that means you are injecting faults on purpose, your infrastructure, to see what will happen. If you, for example, if network goes down, your CPU is on high pressure or your memory, there's a memory pressure, you can simulate this kind of stuff and you can see how your application or your infrastructure is resilient or not. Okay, there are some key points. So the purpose is increase the resiliency and able to react features, because if you see a failure in your infrastructure and if you're in a panic, it could be worse. And other one is applying chaos principle continuously, because it is not a simple task on your Azure board. Okay, I applied chaos engineering and I am done. You must do it continuously. And the other one is creating an chaos engineering team. I know it might not be realistic because you need more resources. But if you have a platform engineering team or DevOps team, you can assign tasks to them and apply some chaos engineering principles. And the last one is the best practices. So there are 4 best practices. Let's start for the first one. The shift left is experiment early and experiment often, which means you can do it on your dev or test environment, which is safe. And if you want to experience the real chaos, the second one is shift right scenarios. You can do it on your production environment with the real customer load. I don't recommend it, but if you really trust your environment, you can try that one. And any first-person shooter gamers here? One, okay. I think you know the blast radius. If you throw a frag grenade and you hurt your team, it causes a friendly fire, and it is not good. It is the same thing here. So if you start experimenting, and if you go beyond your scope, for example, I am applying chaos engineering one of my applications, and if I'm going to make the whole environment and makes everything down, it would not be good for the company and for your career. So the last one is the most important one. It is the budget. In previous slide, I said about the chaos engineering team. You need to establish a budget for this kind of stuff because it is very important as your infrastructure. So when to apply chaos? When you deploy a new code, which means you change something on your application. And the other one is adding dependencies. For example, you have a microservice application, and you edit new microservices or maybe new APIs. You need to test it again. And other one is observing changes in usage patterns. For example, if customers using 2 APIs, and the third API is not used mostly, you can apply chaos engineering to the first 2 API, but a couple of months later, maybe customers start using the third API, and their usage pattern change, and you need to, for example, apply some chaos engineering, some to try customer loads on that API. So any questions? Okay. So I am going to try to make a demo because it is still in preview, and please expect some problems. And hopefully I will make it properly. Yes. So in my demo environment, there are 2 Ubuntu VMs, the Docker installed, and there is a container image running called it's the Terraform Whoami image. It is just a tiny Go server, just saying my IP is, my ID is this one, like this, and I have a load balancer in front of these 2 machines. Let's have a look if these are working. And let's go back to the history. Okay, 2 seconds. Okay, I am going to run a infinite loop. In every 2 seconds, I will send a request to the load balancer and see if it's working. Font size is okay for everyone. Okay. Okay, you can see this is the first one and this is the second one. It is like the round robin. Okay. So let's apply some chaos. Okay, if you are not familiar with Azure Portal, first of all, you need to go to your subscription and resource providers. And register Microsoft Chaos. So let's go back. Okay, I know you might be disappointed. Just 2 options here. Chaos Studio is not a resource. It's a tool. You can think like the Visual Studio. And as I mentioned before, there are 2 options here, targets and experiments. Let's start with the targets. Okay, I can see my all resources that I can apply experiments here. For example, I can see my virtual machines. Also, I can see my network stuff here because I can also apply network faults. So let's start with the VMs. First of all, I am going to select the resource, and here an option, enable targets. We have two options. First one is service direct targets, which means I am going to break Azure services. Second one is agent-based targets. This one is install agents in the VM, and I am going to try to break inside the VM. It is not for the resource. It's for the application or the operating system. Okay. So let's start with service direct before. Okay, I think it is okay. So I can see the service direct is enabled. So let's start create some experiments. This is the part I will create actual resources. The experiment is a resource, so I'll create a new one. Let's select our resource group, name, let's say there's one. There are not so much options. You know, this is the standard resource creation. In the second part, we will create some experiments. You can create multiple steps. For example, first I will create a CPU pressure. After that, I will create a memory pressure. And after that, I will stop the VM, and you can create multiple steps to see how it works. Let's start with a simple step. And I am going to add an action. I can add a fault or I can add a delay. Let's start with fault. Okay, there are lots of predefined faults. You can see for AKS, class service shutdown, CPU pressure, disk pressure, key vault deny access. There are lots of stuff here. As far as I know, there is no customized faults right now, but maybe later Microsoft give that advantage to us. And let's start with VM shutdown. It's the basic example. The minimum duration is 5, and I will click the abrupt shutdown. It means like pulling the plug. Okay. Okay. So now I am going to select my resource. I only installed this one, so I can only see that resource. Okay. Yeah, I think so. So, okay, let's start again. Okay, I edit my action. I can see the details here. Okay, so let's create. Now it's creating an Azure resource. Okay. So now we have an experiment. Let's start it and see how it works. Okay, so okay, it's failed. Let's have a look. So can you see it? I got access denied error because I am trying to access my virtual machine, which is another resource. So I need to give some permissions to this resource to access my virtual machine. So I'll go back to virtual machine. I'm going to add a rule assignments. I think the virtual machine contributor is enough. Okay. I'm adding my chaos experiment. Okay. Okay, I've edited. Let's go back to Chaos Studio again. Okay, I will run it. Sometimes you need to wait a couple of minutes before starting again, but let's see if it works. It's failed. Let's have a look at the details. Yes, I need to start again. Any questions so far? Okay, it seems working. Okay, now our experiment is running. Let's run our infinite loop again. Okay, it's not going to VM1, only it's going to VM2. Let's check on Azure portal. Okay, the key point is the chaos experiments is not a simulation. It is actually stopped the virtual machine right now. That's why I say, if you want real chaos, you can try in production. If you think it's a simulation and apply everything on your production environment, you can break everything, and no one wants it because it is very dangerous. So please be careful when you try it in your production environment. And I want to make another demo. I think, Poornima, we have time, right? Yeah, okay. So I'll go back to Chaos Studio and experiments. Okay, I'll stop this experiment. Okay, it's canceling. Let's go back to virtual machine. When you stop your experiment, as you can see, the virtual machine started automatically. So you don't need to go to the resource and start or whatever. So this time I am going to inject another fault. I select the same VM again, and this time I enabled agent-based target. And this time it asks for a managed identity. So I am going to create a new one. The resource. Okay, it is asking for a create managed identity because I need that identity to access the resource. Okay, so yes, sorry. It's not enabled. Yeah. You can integrate application insights, but this demo I'm not going to do it. Let's say disabled. By the way, there are some limitations for the agent installation. You cannot install agents for every operating system. I can share the link for the limitations. I am using Ubuntu VM here, and I think if I recall correctly, it is required to install ng-stress, which is already installed in that Ubuntu VM. Okay, so I'll create another experiment. Okay, let's say 2. Add a new fault. And this time I am going to select CPU pressure. You can adjust the pressure level. And I'll target here 1, okay. Let's start. So I forgot something, right? So let's stop it, and because it's a new experiment, another resource, so I need to give another access permission. I'm going to the Chaos VM. But this time I am not going to use virtual machine contributor. I'm going to use the reader access. And when I first trying to create experiments, I thought it was included in the virtual machine contributor because it's a reader, but it is not included. So you need to assign separately. This one. There. Okay, let's look at why it's failed again. Try that one again. So let's check. Start. Is it the correct one? Yes. Okay, now it's running. And okay, you can see the ng stress tool. It is now applying pressure to the CPU. As I said, it is pre-installed on Ubuntu. If you are using a different distribution, you need to install ng stress before using CPU pressure. Or if are there any requirements, you need to install them before running any experiments. So before I finish, I'd like to share the... Okay, this is the official documentation. Sorry. Yeah. You can see the which resources supported or what can you do with the Azure Chaos Studio or the experiment details or some nice samples. Okay, any questions?
We unfortunately don't have time for questions, but we'll, of course, Mert's going to be around all day and you can
Yes,
you can
I will
grab
be
him.
around. So if you have any questions or if you like to try other experiments, I will be around here so we can have a look at together. Okay, thank you very much.
Fantastic. Let's give Mert a round of applause. Okay, so coming up now, we have a session from Marcel Lupo on passwordless authentication with GitHub and Azure and federated credentials, and it all sounds incredibly interesting. So give us 30 seconds and we'll be swapping presenters.
Yeah.
speak.
Yeah. Can you hear me all right?
I reckon we can. Let's go with that.
Okay. Sorry about that. Yeah, so basically GitHub and Azure have extensive user bases. So what you can do is you federate those two and use, like I said, more of an identity-driven approach, almost like managed identities, or if you've used them. So it also provides, it's a secure standard protocol for authentication. It's quite scalable. You can add lots of projects, and I'll show you how you can add multiple projects and things like that, because for consistency. And the basically core of it is that it secures the authentication between GitHub and Azure. So, I mean, that's it for me for slides, really, because I'd like to show you this instead, how this all works. So I do have a GitHub repository that I've set up as a demo for today. And what we're going to do is basically going to start up a code space here real quick, just to jump into the code. I'll just open that in my browser. Because we're going to set up a service connection or app registration that we're going to link with GitHub Actions. Now, in Azure DevOps, that would be your service connection. And in GitHub, you create the same sort of service connection, but you have to add secrets into the GitHub repository for it to be able to authenticate into Azure. So what we're going to do first is I've got a script here. And I'm just going to switch to the PowerShell. And just going to log into Azure here. It's just a Azure CLI script that is going to create our service connection. Oops, it's not seem like it's running. Just give me a moment. Let me just open another shell here. Okay, I can't run that. Just going to open this in Visual Studio Code here for a moment, real quick. Just out of curiosity, who uses code spaces? Have you ever used code spaces? Okay. It's pretty cool. I'm just gonna jump into here. There we go. There's the terminal here. Let me just paste that in here. Okay. Let's see if that is logged in. Sorry, having a bit of trouble logging into my session here. All right, there we go. So what we're going to do basically is we're going to create an app called GitHub Global Azure Actions Open ID Connect. It's just an app registration. And I'm just going to give it a contributor access. So just to explain a little bit how this code, what this code is doing. I've got my GitHub org name or username, a repo that I'm going to link it to. And then what we're going to do with that app registration is basically federate it with GitHub. And I'll show you afterwards in the portal how you can add additional, almost like issuers for that federation, because there's different ways that we can, that we're going to do, that we can basically link this, account with Azure. So for example, what I'm going to do here is going to create a federated credential on that identity that is going to be linked with my GitHub master branch. But I will also add a federation that will kind of initiate if there is a pull request. So anything that's on a master, that's basically on a branch or on a pull request. And just to show you the different types of federations that you can set up, so you can basically link a federation of the account with a specific environment. So what I mean, what it does basically is when your GitHub action runs and does something in Azure, it will authenticate based on a branch maybe that you run that pipeline against, or that GitHub actions against, or it could be based on a pull request, it could be based on an environment, and these are just the different constructs. But I'll show you that in just a moment. We're going to do it on specifically a master branch and also based on a pull request. So just having a look at the code here. This is just building that kind of credential. And then the app, I'm going to give that contributor access over the subscription. Now, you don't have to do that. So for example, if your service connection or GitHub action is maybe writing data to a storage account, you can use that identity using the RBAC access to just give your identity access to whatever it needs access to in Azure. But I'm just going to use the contributor there. So I'm just going to run all this code here. It should hopefully create all that. So if we have a look at our app registrations. Oh, that didn't run. Oh, goodness me, I don't know why I can't run this here. Just try running it in here again. All right, so this is just going to create the app ID. Sorry, it's logged me out again here. Let me just get back. One moment. Hopefully that will create it this time. Okay, so I'll refresh that. Okay, I mean, it's not created it for some reason. Let me, and I can't run the code in the shell for some reason, but I've got a GitHub, well, a service connection here, and I wanted to kind of show you how you do that, how you can do that federated credential. So if you go to clients, certificates, and secrets, you have this tab here called federated credentials. So what you can do is you can add a credential, a federation between GitHub Actions and Azure resources. So for example, what I would do is I would give it my org name, which is PWD 9000. Well, I can give it the repository name, which is going to be this repository here. Go and copy that. And here's where I was talking about the type, whether you can do an environment, a branch, a pull request, or a tag. So we can do it on the branch. My branch is going to be the master branch. And that's how it constructs the subject and identifier. Now, if I selected like pull request, we'll do a pull request one as well. And we could just call this master branch ID connect. I'm going to add that federation. And what we can do is we can add another one, and we will do that based on the repository, but do this one based on a pull request, for example. And you'll see that it changes the subject identifier a little bit. Okay, and add that. Now, what we need to do before this federation can actually work is we have to set up on this repository that we have, we have to set up some GitHub Action secrets. So if we go to the secrets, you can find it. Secrets and variables here. Now, if you've used service connections before, here is where you would put the client ID and client secret for it to use that that credential. Like a service connection in Azure DevOps is the same sort of thing, but you would have to use a secret. So what we're going to do for our secrets is, so we've got basically a workflow that will use that, will log into Azure, but all we need to add is the client ID, the tenant ID, and the Azure subscription ID. And then what we'll do, because that identity has got contributor access over the subscription, we're then basically going to log in and then run a command on the actions runner that is just going to show the account and maybe list all the resource groups. But like I said, that identity, this identity here, I can give it certain access to do you know, what I want it to do, basically, like through RBAC. So So what I can do, for example, I need to just double check. So it's called GitHub ACI deploy. I'm just going to take that to the subscription here. Going to add the RBAC or the role assignment for, let's say, contributor, maybe. There we go. Add that. And then we'll add our app. And this is now where we're going to basically do that. We're going to take that app and create the secrets real quick. Oh, okay. So it must have just taken a little bit of time, but it did create my app actually here through that PowerShell code. So just to quickly recap and show you, these are, you see there's no client certificates, there's no secrets, and there's the two federated credentials that I was going to run there. So what I can do now with this app registration is basically just take its application ID, and I'm going to add a secret in here, which is called Azure Client ID. I'm just going to paste that in here. I'm going to take the tenant ID. Going to add that as a secret as well. And it's just called Azure Tenant ID. And then the last thing I need to do is just get the subscription. And we'll just take the subscription ID here. Whoops. The Azure subscription ID. There we go. So as you can see, there is no client secret in this environment variables, and this is for me the key thing that I kind of want to. The key benefit of this is that there is no password, there is no secret that can expire after 2 years. And you can link this identity now with. Just quickly jumping back to Azure, to that credential, because remember that's linked to my master branch and my pull request. So if I run my workflow, my actions workflow here, just going to quickly do a run of that. Remember the code for our workflow is going to basically log into Azure using that identity, and then it's going to do an account show and an account list. But this is linked to my master branch, or if I did a pull request, say I had some sort of application that gets triggered by a pull request on my master branch, that's the only time that this identity will talk to Azure AD, get a token, and basically execute the tasks. So let's take a look at that real quick. You can see here that it's logged in using that identity, and it's run some commands. So basically, it shows me the subscription that I'm logged into, and it also shows me what resource groups I have in that. But you can have now, you can run with this identity. And just quickly, just to show you, if you've had multiple repositories and you want to use the same identity and not worry, I mean, you can separate them, but just to show you real quick, if we go to the registrations again, and if you wanted to, so I added the federation for my project and the branch on master, and this one is for pull request. But what I can do again, like I said, you can add multiple orgs, repositories, and then based on these types. So even if you want to use just one identity across, maybe you have 2 orgs or maybe 3 or 4 repositories that kind of work on the same thing or needs the same sort of access, it cuts down on all those service connections by having a service connection. Obviously, that service connection has to be linked with certain permissions. So maybe if you have different service connections for different permissions that you want to give a repo only certain access, then yeah, you can split them up. But you know, if you've got, if you're deploying infrastructure, for example, through automation, you can use, and maybe you have a few different repositories, they all kind of need the same sort of access. You can use one identity in this way and link that up with your GitHub actions. Yeah, and that's all I have really about GitHub actions and OpenID Connect. There's my details again. There were a few hiccups with the demo, but we got there in the end. Was there any questions at all from anyone?
Any questions from Marcel in the room? We've not got any in the chat, but anyone want to ask anything here? Or you just want your lunch? Just want lunch. Let's give Marcel a round of applause.
Thank you. Thank you again. Ready.
Well, thank you again, Marcel. Yeah, we have lunch here. Just hold that a sec. So we have lunch here now for the next 45 minutes or so. For people watching at home, I'm sorry, you're going to have to go and have your own lunch. But for people in the room, go and enjoy it. We also have a talk coming up during lunch. So if you want to grab some food and come back and watch, there'll be a virtual talk about Open AI, which is definitely a hot topic coming up soon. But otherwise, thanks again, Marcel.
Thank you.
And we'll see you back in a bit.
Thanks, everybody. Thanks for coming today. Okay. I'll touch that.
Hey folks, for anyone that would like to watch a virtual talk about OpenAI, an introduction to OpenAI by our wonderful speaker coming up now, Usama, we'll be getting started right about now. I'm thrilled to introduce Usama. Usama's based in Dubai. He's talking for us remotely, but I expect this will be a particularly interesting topic that you can watch now as well, if you'd like, or if you're still finishing your pizza, that's more than okay as well. Hey, Usama, I'm just adding you into the stream now, and I think we have your slides.
Hello everyone. Good afternoon. Hello, London. How are you guys? And first of all, thank you for giving me this opportunity. I was supposed to be there, but unfortunately, I got in a motorbike accident. I hurt my shoulders and arms very badly. Couldn't be able to make London at this time. However, I'm missing the in-person meetings. And I know there was a tons of amazing session has been delivered by my co-fellows. So kudos to everyone who have done, and I enjoyed totally the last one especially. Thank you, Poornima, and everybody to making this effort and everybody participating in this contest. I'm really excited about the today's topic that's called the OpenAI. Let me quickly give the short introduction. I already been introduced by my friend. Today we're going to talk about OpenAI. It's a buzzword in the market. Everybody wants an AI. AI is really getting started on. At this moment, believe me or not, in Dubai, everyone is talking about AI. AI is on asteroids out there. So, we want to make sure that when we're going for any technology adoption, we have all the ingredients. We know the technology inside out from every single aspect, from responsibility, for compliance, from governance, for security, for control. And there are so many fascinating things that are available out in the market. But when it's come for enterprise-grade implementations, they're not ready. But the OpenAI is one of them. It does not only making buzz, but also ready to use as well. So today, I'm going to talking about OpenAI at Azure. My name is Usama Wahab Khan, and I am Microsoft Most Valuable Professional and certified developer, DevOps, or there are lots of things. I'm basically Microsoft certified trainer, deliver 500 training across the globe, currently based in Dubai, working as Chief Technology Officer at Evolution Technologies, ex-alumni MIT. And more important, I'm a father of two beautiful, gorgeous daughters, Manha and Lena. Lena's photo is just missing it somehow. And I'm running also DevOps and data engineering and Azure developer community in Dubai. So anyone who'd stop by Dubai, please participate in our event online and physical as well. So let's get started. So first of all, we're going to talk about the OpenAI. So what is an OpenAI? OpenAI is a descriptive development of generative models that are trained by a very large number of parameters. But before we get into the segment of OpenAI, where this OpenAI thing's coming out there, OpenAI makes AI model available for developers. OpenAI make this model available, and the build is so powerful with so many big, large amount of data sets or large amount of parameters that is being used to train these models out there. These models are humongous. Microsoft Azure provide a supercomputer for that, where they can be used out there, where they can develop that kind of model out there. But if we take a look, it's not something very new. It's been there for quite a long time. We don't have the compute power like that or the kind of data that we can process. Now we have that capability. That's why this system becoming so immersive, and it becomes so live, I can say, so popular in the form of ChatGPT and other ones out there. So first of all, what is artificial intelligence? The biggest category is the biggest Uber if you talk about, it's an artificial intelligence. Artificial intelligence imitate the human behaviors by relying on machine learn tasks and executing without explicit directions. Traditional software development that we do, it also mimic the human step or human capabilities or functionalities out there, but they require a very descriptive directions. And it's kind of like an auto direction that's make a machine learning or artificial intelligence more attractive. So artificial intelligence is a bigger Uber, and this particular segment we have something we call machine learning. Machine learning, we as a data scientist pick a statistical or machine learning algorithms and train our model based on that, so they can make prediction on the data labels that we didn't train on it. So we try to find the patterns and the how we can predict the next words out there, or the next content, or the next segments out there. And an advancement in this particular topic, when we go furthermore in this particular area of machine learning, there's a one specific segment or one inspiring segment of machine learning that called deep learning. Deep learning use layer-based model algorithms in form of artificial neural network, like brain works. It just connect to the multiple points and establish a relationship between them. It can predict the next level or the next point, what selectively can be possible out there. Deep learning, it's making buzz in this industry from quite long. You have heard lots of things from Google. You have heard things from so many different points, so places out there. Deep learning, it's a machine learning technique that teach computers to do what comes natural to humans out there. And it learned, for example, deep learning is basically a main technology behind the scenes, the autonomous cars, behind the also generative AI and many other forms. One of the recent time advancement in the world of deep learning and in the world of artificial neural networks, we able to develop a so smart and so large neural network, it can almost predict the words or process things like human mind can do out there, which is fascinating and also scary as well. So deep learning can be considered as a subset of machine learning. It is a field that based on learning and improving at its own by examining the algorithm. And while machine learning use or simpler concept out there, deep learning works with artificial neural networks, which is slightly a more complex and more advanced form of training models out there. It simulates the same way that human brain works. And we try to find different kind of algorithm to build different kind of neural networks to basically achieve a better outcomes. Also, the black box, that's another scary thing. The way the brain works, the way the brain can process data or signals in order to generate results, same way AI now can do out there. But it's in a black box. We don't know how these models are being trained. We don't know how those signals are processing. And it's very difficult to debug. It's very difficult to debug how this neural network will process the single signals. And that's another key thing in the world of AI that Microsoft also contributing in it in order to overcome that particular challenge. However, it's not fully complete, I can say. So artificial neural networks is basically compressed of multiple, multiple layers, and drive a deep learning neural networks, or DDNs, are the such type of neural network where each layer can perform a complex operation such as representation or abstraction of a sense or detecting image, or might be different context out there. I don't want to go deep dive into a machine learning or deep learning out there, but one of the most advanced form of a machine learning and deep learning we have in a form of generative AI. Generative AI is a new word or a new buzzword in the industry. Generative AI models can produce new content based on a description that you provide in a form of input. Most probably people call it nowadays the way that you provide this input as prompt. So like in a prompt engineering, might you have heard that word out there. And OpenAI is one of the companies that is really leading forward in this particular area. OpenAI built the open source machine learning models, deep learning models out there are a collection of a generative models out there. So they have built 6, 7, or more than 7 basically generative AI model which perform different kind of tasks out there. We're going to learn about what those tasks out there. So majorly, they are currently work on 3 different areas. One is basically they talk about the language. So they can process different kind of languages and natural language processing, and also related tasks to it. So generating summarization, tokenization, prediction, all those things about the text they can do like human. And they can also use, we can also use or train our model on programming, on software code or software programming, I can say. So the way that we write software is write up computer programming. Same way we can train our models so they can predict the right piece of code, or they can guide us in the code. So the task related to the code, the understanding the code, writing code, or generating code, verifying code, providing assessment on the code, summarization on a code, evaluating on the code. So the thing that human can do by reading those complex scripts and scriptures out there. And now these machine learning model can do that. And they can do so efficiently that it's really scary and also surprising as well. We can generate images by providing a very basic information, and artificial intelligence will take those images and use their large scale language models to basically process data and generate images for us out there. Second question that you might have heard of it, that why Azure? And Azure can, first of all, Azure has participated heavily in a build or an execution or preparation of or training of OpenAI models out there. You can also bring a large scale AI models with Azure, and there are several advantages. Many people have asked me that why we're going to pick Azure for the large language models. There are lots of other options that are available. Even OpenAI, they can directly provide you services as well. There are lots of open source tools and large language models are available. Why should we go with Azure? Taking advantage of a large scale models, generative models, and the deep learning, it's required you to understand the code, and Microsoft has tried to simplify in a form of API. You don't need to really worry about the comprehensions behind that. You don't really need to worry about all the infrastructure that beneath that. Another challenge with the AI models is compliance and responsibility, that how responsible those AI models are, how compliant, and we're talking about AI ethics, that how much they take into account for the transparency of those models, how much harmful those models are, how much biased those models are, how they've been trained, and all those need some level of certifications out there. They need some level of trust to develop between the vendor and the consumer. And Microsoft filling that bridge. So you can also, first of all, not only use an OpenAI model in Microsoft with all the Azure goodness, it's more compliant than anyone else. Any other cloud offering, ISO, CMI, HAPA, RSI, these are almost 300 plus different compliance certification that Microsoft has available for their Azure infrastructure. Enterprise grade security has been available, and these features are seamlessly integrated with the OpenAI model, which make you a great destination, to run such workload like OpenAI models or large scale application models, and fine tune them with your given data with privacy and security in mind. It's like an isolated, separate, and tailor-made, trusted instance of an OpenAI model. That what you can do in OpenAI capabilities, but it is only specific for your organizational needs. You can fine-tune furthermore out there. You can provide your data and hyperparameter to fine-tune the data according to your requirement. You can use the built-in features integrated with other Azure AI technologies, like cognitive services. And you have capability to control and access that how this data and model make it available to your applications, how this data will be available to others as well. So you have a complete control over the access management, over the networking, and every single aspect of it. So it makes it more trustworthy and more easy to implement out there. If you take a look at the portfolio of Microsoft AI, it's evolving very rapidly out there. So AI is nothing new to Microsoft. Microsoft has heavily invested in past and has created some decent amount of progress, I must say, and some very useful services out there. So we have applied AI services, cognitive services, form recognition, and we also have video indexer, metric analyzers, impulsive readers. These are the applied services that you have seen or have you seen out there. Microsoft Cognitive Services is a platform behind those services or those solutions that we can use. And so Microsoft provide an API for ready-to-use AI services such as speech, vision, language, decisions, and now OpenAI as well. But the best part, Microsoft is a complete stake for everyone. So the people coming from a business applications, so no code solutions can also take an advantage of an OpenAI. So they have an OpenAI builder, AI builder, and AI agents that you can use to build your bots without writing a single line of code. You can use these particular languages, these particular APIs from Microsoft platform as a PaaS platform as service, which means you don't care about the infrastructure. And you can use these pre-built services, pre-trained model, or ready-made AI to embed them in your applications and embed the AI capabilities and build a modern fashion applications as well. But you can't fit the ready-made things. Sometimes can do the job, but they're not the best fit for your requirements. So Microsoft have a great infrastructure for machine learning. So they have a machine learning workspace and the computer resources in a very unified environment where you can build your custom trained models out there. Even OpenAI is built on Microsoft platform. So you can see, you can imagine what kind of things we can build with it as well. So if organization decided to build their own custom model, they want to use scikit-learn, any Python library, TensorFlow, whatever their favorite machine learning or deep learning libraries, whatever the kind of compute they're looking for, and whatever their requirement of size in terms of scale, Microsoft has enough beef available that everybody can take piece of it. That's why enterprises heavily extending out there. In Dubai, we have implemented OpenAI in many organizations and many perspectives as well. So it's the best place to run the AI workloads because, again, it's very powerful. It provides you the resources that you needed in a glimpse of price, and the availability of these supercomputers and these super trained resources that must required for large learning models is easily available for us, so we can fine tune for our data. Microsoft has heavily invested in OpenAI, the largest partner in OpenAI. And Azure OpenAI service is a result of a partnership between Microsoft and OpenAI. And this service combined the greatness of Azure enterprise capabilities and embedded them and deeply integrated them within OpenAI APIs. What is the result? Number one, it available for the users so they can consider the 4 different components: pre-trained models for generative AIs, customization capability, the ability to fine-tune your model. So once you basically get an OpenAI model, it can really predict and do things, but many organizations don't want to give their own data to OpenAI they can train or they can use for that processing out there. Or they want their systems to be trained and optimized according to their work needs, like financial institutions, medical institutes, they have a financial data, medical data, or geographical information systems. They want to get advantage of it, and they want to use an OpenAI capability. They want to do a summarization, tokenization, and all that, but they want to fine tune. They want to furthermore optimize so results becomes more easier or more realistic. That you can do. Also, these are built-in tools that can help you to detect, migrate the harmful use cases, and implement a responsible AI. One of the key things that Microsoft has able to achieve, and enterprise-grade security. So when you're working with the data, the security comes first in your mind. All of those things filtered in a single packet out there. You can use the OpenAI that can allow you to translate between your work with Azure services and OpenAI. You can utilize a private virtual networking. You can select the region availability and responsible AI for filtering content that you think so it's not appropriate or require a moderation. So what kind of workloads OpenAI can support today in Azure? General language detection, so natural language processing, text completion, embedding, search. So embedding can cover the search, classification, and comparison of target text and documents. So we can build a modern knowledge bases. We can build a more advanced text summarizations and code generations as well. We can also do a code generation. We can also do image generations as well. So we have a multiple components available. When it's come for natural language processing, we have a capability of texting and embedding such as search, classify, and compare text. Generating is editing and modification of text as well, and the code is also can work in the same fashion. Even we can create a model that can explain code that can help us to build automation in a testing or other kind of DevOps processes. OpenAI models are solving AI workloads that can be categorized into 3 different categories or 3 different groups. Azure Machine Learning Platform, Concurrent Services, and Applied AI. If you can see that in my previous diagram, I have just categorized them earlier as well. If you talk about that how Microsoft is being engaged with this process, so Microsoft is been within OpenAI for a very long time as well. And Microsoft introduced OpenAI on their platform earlier in a strategic partnership in 2019, and it's keep evolving over the period of time. Recently, they have introduced Codex model, which basically implemented by also in 2021 by the GitHub called Copilot. And the Copilot is using a same OI model, and in order to help you to write code, generate code, or processor work as an Copilot or working as an pair programming. Some OpenAI examples what we can do with an OpenAI. So OpenAI can do a grammar corrections. They can be in a QA. Models can be developed out there. Text summarizations out there. Natural language processing API that we can build a more better or more understandable bots out there. We can do a text commands that can be convert our command into programmatical languages or commandlets that can help us to create systems that can process natural language much more smoother, much more better than ever before. We can write T-SQL queries and from natural languages as well. So we can in future say that join the table 1 from table 2 and it can generate a SQL query. It can help us to process and parsing data or create a complete data pipeline by sliding few lines of simple English. And imagine that you are working on a Databricks, you're working on Spark, and you want to create a complete data pipeline. And this pipeline requires a lot of transformation and advanced optimization as well. You can write few lines of codes, and the rest will be fun. That will be generated by the systems. And that's a dimension where we're heading up out there. And I have tweeted a few months back that everyone should know that where we are heading towards. Learn programming with an AI, learn building software with AI, otherwise you will left behind. And it's the same way that we adopted cloud in the past decade. I think so this decade is more focusing on AI, that AI is not going to replace us. We have to learn how we can write better with AI. Now the competitions will be much more higher and people have different opinion. I respect that. Microsoft initially provide you the OpenAI access, but you cannot just is general availability. You have to apply for an access, and there's a form available, and you can see the link here. And this particular form required that you have to go and fill this information and provide that particular subscription and requirement because a huge demand. This is not something that you can provision other resources. So you have to go on this little on my Twitter profile. I'll put the complete links if anybody want to follow up for later on for this presentation. So this form has initially issues, so you have to provide some information, and based on their quota, based on the priorities, they will allow you to create Azure OpenAI resource in your tenant. Once you create a resource in tenant, you have an Open Studio. OpenAI Studio. If you talk about the OpenAI Studio is like one single model where you can, or one single place where you have all the services that you can test, run, and there are lots of use cases where you can do some fine tuning. You can do your prompt engineering before you embed thing in your application. So it's a Microsoft pre-built application where it can help you to play with the pre-trained models. And this is kind of fun, and you can really use this OpenAI Studio, and it's a very friendly UI, and you can see a list of capabilities and different models that you can test, and there are lots of use cases that you can really try the browser, and you can also have so much advanced fine-tuning capabilities here as well. Playground, you can start testing your model with the different prompts, and if it's already available in the list of examples, you can just keep it running out there. If not, you can fine-tune and you can provide your own specs there. If you can, let me just zoom it. If I can zoom, it's not take much time. So you can fine-tune the sentence and the parameters. So this is basically the quick view of Microsoft Playground. So the temperature is, if you can see there are all the multiple parameters based on a kind of model that you select. And there are different models available which basically have different kind of capabilities. We're going to talk about the models as well, that what capabilities and models are available. But the Playground gives you the opportunity that you can tune these model behaviors as well in order to generate a right prompt or generate a right results from your prompt out there. So if you talk, we also have a ChatGPT. This example here, you can see that we have a summarization, and we can just provide the prompt for text summarization, and ChatGPT will basically generate it as a result. Microsoft currently offer 3 different models at this moment out there. We categorize them. We call ChatGPT. Now ChatGPT 4 is also available. So ChatGPT, and we have a ChatGPT. We have 3 different models. And we also have a Codex. ChatGPT is a text model out there, and this model can understand and generate a natural language. And among a ChatGPT model, like a DaVinci is the most capable one, but Adia and there's the most fastest one. So there are multiple models. I'll talk about that one in a moment. Then we have a Codex. Codex is another model that OpenAI offer, and this model that you can use to understand or generate code or translate code. So it's related to programming languages. So if you want to build something for your own programming language or a specific plugin for the any programming language, you can use that one, fine tune and integrate that one with an API. And the third one is a DALL-E 2 or DALL-E 3 that called embedding. It's basically focusing on embedding. And so it uses embedding, which means that representing the word or a sentence with a multi-dimensionality in space out there. So there are 3 different models that are available, or 3 different categories of models available. And each category, we have a bunch of different capabilities. So currently, if we talk about the ChatGPT, so we have a ChatGPT 4 and ChatGPT 3 available. We have a DALL-E and embedding available and Codex. So these are the models available. OpenAI can all be trained and customized and fine-tuned. So you wouldn't need to do a custom model out there, but you can fine-tune your models. So you can pick any of these models that are pre-trained with the billions of parameters, but still you can optimize them. You can fine-tune them according to your requirement. You have to select a model, you have to provide the data and the validation, and the automatic process will help you to generate the results the way that you want. And that's the power of Azure that you can do. So if you go on OpenAI and you feel that, okay, it's a great tool, but it's not recognizing my structure of a data or my results, I can optimize here and get the same level of power that I want. So, as I say that there are 3 different models are available. And if you basically talk about the OpenAI models, ChatGPT is getting a more popularity in this particular segment. And so it talk about the all text summarization, and it also talk about all form of different capabilities and prompts. If you talk about the prompt out there, so the prompt means that how you provide the instruction to the model out there. So when you talk about the prompt engineering, or we talk about the prompt modeling here, it is very important to understand that how OpenAI can respond to your given instruction. So especially ChatGPT model is completing a several of language tasks out there: summarization, comparison, text answering, suggestions, all that ChatGPT can do out there. But how you provide them your instructions out there? So you provide your instruction in a form of context. And this particular context or input is basically called prompt nowadays. So prompt is a giving information or giving text tokens that the model can understand and predict that what kind of response you need out there. It's the auto completion and like that. So this model of natural language processing becomes super popular, and might be you guys have seen this a prompt engineering thing that's going on across the globe out there. The better the prompt you will provide, the better the tokenization you will provide, the completion, it's the more sophisticated and more reliable results you will get out there. Microsoft integrated Azure Cosmos DB rich cache out there that to optimize and help you to use this process to be more optimized and take these inputs or these prompts from various points as well. And you can use them in your databases and your knowledge bases to basically get the better prompt in order to submit that one into large language models so they can return the much more better and easier results. So prompts are how you get ChatGPT 3 or ChatGPT 4 to do what you want. And it's like I was telling the writing the basic instruction in English and getting the results in form of a text code or other methods as well. So it is important to basically how we can provide a short and better prompt, how we can provide a sample examples. And the ChatGPT model and the Microsoft Playground gives you these samples and opportunities that you can understand, you can learn how you can provide the better prompts, how you can provide them a better instruction so model can provide the results that is required for, or that's the specific results that you're looking forward. And programmers and developers can use various ways, like integrating ChatGPT models with a Microsoft Cognitive Search that can help you to receive the better search content and provide that search content so it can do a summarization based on the given prompt. And this prompt is very important out there. So the prompt design is very important out there. So classification and all those things is very important to understand. So in a very simple word, so in a form of completion, we provide a list of instructions and the sample content and the kind of results that we want. And the Open AI model receive this instruction and the sample data and sample instructions, and provide you the quality completion results as well. That can be text summarization, prediction, generation, and different kind of activities as well. So activities will depend on that what kind of model and task that you assign it. But this thing is make it ChatGPT super easy, but also super difficult to control in order to receive and retrieve your required results from it as well. So this is one sample example. In Azure platform, number and results. So I can just simply write the instruction here, write a function that adds 2 numbers, and that's my prompt. That's my prompt. That's an instruction I'll pass. And the ChatGPT iris data from the scikit-learn library. So I can just provide the basic prompt instruction, load iris data from scikit-learn data sets, and of course, the example I'll give, the better the results I will get out there. So we have a high-level context and description about what we are talking about, what task is in a prompt. We provide some examples and input to make it more improved. And also, it has a session buffer that can keep optimizing from the other related inputs that provide in a single session. So it know the context what we're talking about it, and which make this ChatGPT model super human and like a very human oriented or human nature or like a human style interaction that you can get from this model out there. So you provide them this data, and this data can came from databases like Cosmos DB or a cognitive surf to provide them a high level context with some examples. Okay, that's what we are looking for. That's kind of result that we are assuming. But it's not identical. We just give them a sample templates, and the generation of the code, word, subject, or any kind of text matter, or in fact images, will be according to our given instructions. The better we provide this information, the more better the performance of the model will be. But all this complexity becomes super simplified. You can just use a simple Python API in Microsoft OpenAI as well. You can use this API ID from the resource that you provision in Azure and the endpoint based on which particular model you selected, and just provide the length of tokenization. So a simple call, one single call can basically return you the results and can help you to use this pre-trained models out there. You don't need to write any advanced or sophisticated code, or you don't need to write a model from scratch. It's a ready-made tool. It means you can simply use that one without needing any hustle or any other problems. So one of the use case of a codex that you guys have seen earlier for OpenAI nowadays, and it's a codex. So codex is being implemented into GitHub Copilot, where GitHub Copilot help us to generate codes. So we provide them on an editor context so it can understand that what the code we have written in editor. We provide them suggestions in the form of comments or text, and then we try to keep improving them by adjusting a code or providing a better prompt. And it generates and results into addressing or explaining code or generating code the way you want. You guys might have seen the lots of demos of GitHub Copilot service that help you to generate codes as well. So if I'm going to show you one example, just 1 second. So if you can see this one, come on. Oh, come on. I'm just opening a separate image. Okay, look at this example. This is basically behind the scenes using Codex model for OpenAI and using a plugin from GitHub. So we just provide them a first instructions that what kind of thing that we try to do here. And once a plugin installed, I just have to provide a basic command lines and basic instructions. Comments, the code comments will basically read and recognize that what kind of function that you want to generate, and it write a whole code for me It's write the whole code for me, and it's surprisingly good and surprisingly amazing as well. Code generation, even for image generation, it's memorized audio. We are using the natural language processing. We're using the same model in Power BI to generate insights. So, and also you can practice all those examples with your given choices. The best part, you can integrate that one with the cognitive services, machine learning services, Azure speech services, and transparency, and bring your custom models as well. The best part, the most important one, it's a responsible AI feature. The Microsoft implementation of responsible AI and ethical AI principles that they have implemented that give a sense of security and safety and the privacy of your data that help you to use this model in the most enterprise and most transparent way. I hope so you like my session. It's a quick the tips on iWork. Please keep exploring OpenAI. Microsoft has recently launched a free course. If you have any questions, more than happy to answer that. That's all for me. Thank you.
Thank you so much, Usama. This was an incredibly interesting session. And as I said when I introduced you, OpenAI is clearly a very hot topic right now. So I'm sure there'll be some questions. We don't have time, unfortunately, to take those now, but maybe you can join in on the YouTube chat and take any there. Of course, Usama's Twitter handle is there also if you'd like to ask him somewhere like Twitter. Anyway, now we actually have our next session, which is not showing on the screen. 1 second, sorry. That's also not showing on the screen. You can tell we're not used to doing this. Well, hey, cool. So coming up next, we have a look at Terraform and Bicep by Nicholas and Mark, who are going to be looking at the infrastructure as code topic. It's something that I've not dabbled too much with, but I'll be very interested to see where things are now. I've not touched Bicep myself yet. So let's give Nick and Mark a round of applause as they come on stage. PowerPoint. I'll leave it to you. Oh, shit.
Excellent. It's definitely a slide.
Okay, let's go.
Yep. Okay, well, thanks everyone for coming along to Global Azure. Particular thanks to the people in the audience who are full of pizza and yet still haven't fallen asleep yet, which is very impressive. Also, thanks to the sponsors. These are the people who keep the lights on, pay for the venue, all that sort of good stuff. So go and buy their products and apply for their jobs and all the things that they want you to do. Now, this is Nick's talk, so I will let him explain briefly what we're going to be talking about.
So in this talk, I'm going to give you an overview on how you can use Terraform and Bicep to deploy resources in Azure, and there's going to be a live demo at the end. So who am I? So I'm a platform engineer at Kainos, working for a Microsoft partner that works with different providers like Azure.
Screen share. Could we just hang on.
Sorry. Minor technical difficulties again.
Sorry.
Ooh.
We were seeing, yeah, that. Right, let's try that again. Slide, no. Screen. You wanted your entire screen. Right?
Yeah.
Entire screen, but it's not showing the correct display. Can we just share? Oh, you had this problem, Will, right? Where it doesn't show the screen?
Yeah.
What did you do?
I projected my screen, so I had two screens to share.
That's what's happening here. Display.
No.
Do you need your speaker notes?
I don't.
No,
No?
don't.
You fine? Okay. We're going to go with that and share. and go back to your PowerPoint. There we go.
Okay. So who am I? Sorry. Ready? Sorry, technical difficulty.
Sorry. This worked fine like 10 seconds ago. Oh, that's presenter mode, right? So can we just do slideshow, play from start without presenter mode?
It always gives you presenter mode.
Let's try that.
Okay. Welcome to Global Azure. Lovely sponsors. Talking about infrastructure as code. This is Nick.
Okay, so who am I? I'm currently a platform engineer working for Kainos, a Microsoft partner, and we deal and work with Microsoft, Azure, and AWS. And I love technology. In my spare time, I enjoy socializing with friends and family and keeping up to date with technology. So I'm quite active on social media. So you can follow me on Twitter or LinkedIn. And currently have a blog called nicholaschangblog.com, where I try to actively blog what I do. I'm also certified in some of the following Azure certification, for example, Azure Admin certificate, Admin, and Engineer certificate. Sorry.
I'm Mark. I'm a Northern Irish Azure MVP. Well, I'm actually from Manchester, but I lived in Northern Ireland for 20 years, so I'm basically Northern Irish. I'm an Azure MVP. I am Mark XA on absolutely blooming everything on the internet, and that's really all you need to know about me. So what we'll be talking about today, basically Terraform and Bicep. Just a quick introduction. I know some people didn't even know what Terraform was. So Terraform and Bicep are infrastructure as code. So they're a way of basically writing down in a file what you want to exist in Azure. So, you know, I need a database, I need a virtual machine, I need a message service or a service bus or whatever. You put all that down in code and you fire it at something and it makes that happen in the cloud for you. So Nick will talk about Terraform, what it is, how it works, some recommendations. I'll talk about Bicep, same sort of idea. Then we'll do a quick demo of how it works, or at least a walkthrough of the actual code, and then we'll finish off just with a little comparison of the two. And Terraform.
So what is Terraform? So Terraform is a declarative language that allows you to deploy and update, change resources in the cloud and on-prem resources. So there's various Terraform. So there's some Terraform Enterprise and open source. There's some basic commands. For example, there's Terraform init, which allows you to initialize your working directory. And there's Terraform plant. It will let you see your infrastructure preview before you deploy. And there's also apply, which deploy your resources to the cloud. And there's also Terraform destroy, you can tear down, terminate resources that you do not need. So how Terraform works is that it works with Terraform core and Terraform plugin, two concepts. So Terraform core is, you use the concept of write, plan, apply. So you write your code, you plan, you see, you preview your infrastructure, you apply, you deploy the changes as how you want it. And the plugin, Terraform plugins would normally connect, pull the providers from Azure, AWS provider, and connect to the service that you want. And in Terraform, there's a thing called TF state that hold your configuration, your resources all at once, and it's in JSON format. Just hold all your store your resource configuration. So I'm going to tell you about some advanced Terraform. So in Terraform, when I mentioned TF state that store your configuration, there's also, I would recommend using remote state. So remote state could be in S3 bucket, Azure Storage, Terraform Cloud. You can also use it for advanced features. For example, add logic to your your resources, so you can see whether certain add if statement, whether an environment can be deployed in certain conditions or not. You can also use Terraform module, which I'm going to demonstrate in a demo, which is a group of resource Terraform configuration together, and it's Terraform supports CI/CD integration like Azure DevOps and GitHub Actions. And you can also use it for automating testing in Terraform. So you can use it for static code analysis. For example, check whether any have vulnerability in your resource in Terraform code. And some of the major one is check inspect or check off. So this, I wanted to tell you, I wanted to provide some recommendation of people that's going to use Terraform or have not used it, touched it before. So from my experience using Terraform, always trying to use more if statements. If you create more repetitive deployment, like if you want to create 2 resources, multiple resources, always use if statement for each, and avoid using dynamic blocks too much, because dynamic block is a repeatable resources, so it allows you to put 2 resources together within 1 resource, but you have to think of use cases, multiple use cases with it, so it's hard to read, and also have a good folder structure, because when you have Terraform, you need to have good folder structure, naming convention before things work correctly. Never, like when I mentioned the state file, never edit it, so always keep it encrypted, keep it in remote storage, and never touch it unless you have experience of exposure of touching it before you've got advanced level, and always avoid volatile deployment. So what that means is that when you do modules or thing, always consider if certain resources can impact other resources. For example, if you put a load balancer on a storage account in one module, that would tend to impact other storage when you deploy it. So always, when you plan the modules, always consider like module for storage account, module for VNet for each independent resources. Next point is use multi-repo instead of mono-repo. Would mean in a typical infrastructure, you would use, I would recommend to use multi-repo. So have a repo with different modules that you can call for deployment instead of one big repo with different modules. So that's my experience of recommendation. And always follow the KISS principle and dry methodology. So that means that whatever code we write as an engineer or DevOps engineer, anything, we normally keep it simple. So I would think of like, if I write certain code in my Terraform, I need to make sure my new starter in my team is able to understand it. So I had someone in my colleague trying to write code, and then he tried to put more logic into it, but it's quite complicated. So that's from my experience, keep it. And then another point, final point is keep refactoring. So make improvements to your code. So whether it's changing, getting the latest version of module resources, and instead of any breaking change that could happen. So.
Right. Okay, so Terraform is the HashiCorp version of infrastructure as code, works across all the clouds, has lots of plugins and things, very powerful, does lots of fancy things. Bicep is the Microsoft one, which is native to Azure, so it's built into Azure. Are we echoing? Do you want to stand back a bit just in case it's you? Go away. So yeah, I mean, the reason why it's called Bicep is interesting. Basically, in Azure, you have what's called the Azure Resource Manager. And every time you create something or destroy something or change something in Azure, you're doing it through the Azure Resource Manager. And ARM is the Azure Resource Manager. And the first implementation of infrastructure as code in Azure was ARM templates, which were implemented as JSON. And if anybody's ever used JSON, they will know that's a really, really bad idea. So you had this thing, it's really powerful. I mean, obviously you can do anything to anything in Azure because that's what the Azure Resource Manager is for. But it's all put into this horrible declarative thing where it's all sort of strings and objects, and they tried to implement code, a sort of code thing in it, but it didn't really fit. So eventually, after several years, too many years, they decided that they should go from ARM to Bicep. So they completely rewrote how ARM templates worked into a new type of language, which is still declarative, Still allows you to just say, I want a VM, I want a database, I want all the rest of it, but is actually readable and nice, and you don't have to deal with magic strings and stuff. Just to point out on the thing there, I was mentioning that Terraform has all sorts of plugins and things. So, with Terraform, you can do things like provision an AKS cluster and actually then do all the configuration of the AKS cluster in Terraform. Bicep is very much just doing the infrastructure as code bits. So what you'll generally do is you'll have one Bicep file that will create your infrastructure, and then you will run extra commands to do the Kubernetes side of it or whatever it is you want. Excuse me. That's sort of one of the main differences between Bicep and Terraform. The other difference is that Nick was talking about the state file for Terraform, which is where essentially you're trying to remember in a local file what was deployed out to Azure. The nice thing about Bicep is it doesn't use a state file, it uses what's actually in Azure. So if you've got a development environment and somebody's been mucking about with that development environment, if you feed it a Bicep template and say, this is what I want, it will actually go and look what's in Azure already and just make changes to it. So it's what's called a desired state. So it will just change what's there until it is exactly what you've got. And you don't need to check that what you've got in your local file is actually what's the reality of what's out in Azure. So it's a bit like the way Kubernetes works if you've ever done Kubernetes stuff. A couple of recommendations. When you're using a Bicep template, you'll generally be feeding parameters into it. So for instance, if you've got 3 environments that you want to deploy, you'll have slightly different parameters depending on what's the development environment or the staging environment or the production environment. So when you feed parameters into it, the nice thing about Bicep is you can put descriptions on those. You can say this is a secure one, so make sure that it never gets saved anywhere. You can define lengths and stuff, and you can say these are the possible options. So if it's a VM size, you can list all the options. So make sure that you use those parameter descriptions. That's very useful. And it's just all you really need to see from that is that on the left-hand side is the Bicep code, and on the right-hand side is the ARM code. And you can see they've done a lot of work there to make things a lot simpler. Also, if you see that very long line at the bottom of the right-hand side, that's how you have to reference things in ARM. So you really have to put together this magic string by knowing what the names of resources are. That's all gone is Bicep, and it's so beautiful. Anyway. Next, we'll go on to the demo. So we'll let Nick take over and do a bit of Terraform.
So for the demo, I'm going to show you some Terraform, and then my colleague Mark is going to tell you Bicep. So in a Terraform, I'm going to show you how you can use Terraform to create reusable modules. So, okay, sorry. Okay, so to get started with Terraform, if someone knows how to get started, I would recommend this blog by my friend Thomas Stoughton. So it helps people to get started with you have a set up environment and what it is.
Tom's also from Northern Ireland.
Yeah. Otherwise, I would check this blog as well to give you some overview of Terraform, having understand it, but I'll give you the link afterwards. So how it works is that I would in Terraform this. Can you see the code? Oh, let me just zoom in, sorry, just in case you can't see it. So I structure it. This is the Terraform code, and I structure it with environment. So this is how I typically would structure it. So you can have environment for dev, staging, pre-prod, or prod. And then within those, you have your Terraform configuration. And I have the modules, which this copy SRCs for source as well. These are your typical modules that you call it. If, for example, you don't know how to write Terraform any modules, I would recommend going to the Terraform registry. So if you go to Terraform registry, like I mentioned, you got different cloud providers. You can go to Azure, like we're talking about global Azure. So, and then we can go to documentation and type any resource that you want. So for example, PIM. And then it would tell you, give you all those arguments that you need. These are required arguments, and any other arguments like these are optional that you support, you can put it in. So for this, I want to talk about how you can create the modules in Terraform. So when I mention in modules, in the dev modules, we declare it with source parameters, and within source parameter, we put in inputs. So a module can be based with the source arguments, inputs, outputs that you use. So you can reference other module as well to get outputs. And just want to see how it works. Yeah, so we use the important bit of when creating modules is that you need to tell the difference when to put in inputs and environment variables and using defaults. So the environment variables is like the TF files where it's like in Bicep will be the parameters, the values, actual values that pass into runtime. So the difference is that the input modules like the var.account kind would be any of the components that you use reusable in your Terraform code that you keep using constantly. Then we put that as a variable in here. And if there's any like things that want to change in within runtime period, then you put as environment and pass it to, like, you can also pass it to Azure DevOps or GitHub Actions. Otherwise, you could literally put in, like, if for default values like that we know that are static, for example, admin username that would never change, we set it here, that's set to default value. So it's knowing when to use certain variables in Terraform is very vital. As well as having a good naming convention. So we can try to deploy something. So deploy something is quite easy. So like I mentioned, the first thing that you deploy, so put in this. Like when I mentioned, you always use Terraform init. So that would pull all the providers in Terraform any modules. So it would pull the sub modules here. And it will give you, when you click .terraform, all your modules within a .terraform within a JSON. And after that, we would run, sorry, can't see. Oh, yeah. Sorry. Oops, okay. We need to cut that. So we need to do a plan because those are the workflow, the three keys of Terraform command. So the plan would just give you a preview infrastructure. So your actual infrastructure that you want, the desired state against the real infrastructure. So it would give you an overview when it's run. Any moment now. Okay, so while this is running, okay, so it's finished. So let me, I think I've already deployed it. Okay, so brilliant. Okay, so I'll see some of these or like your preview. So this is quite insight because you can actually, before you apply it, you can also preview what you want to deploy and exactly what it is. Sometimes it'll give you confirmation as well. And then to apply, you can just click saying Terraform apply. So that would just apply the resources to your, I think I've already applied it. So let me see on a portal, the resource group. So yeah, I've already deployed. So this is the resource group. It's already deployed, sorry. And I want to show you what it looks like, the states file. So when you go to the state file, for example, here, go into containers, because it's normally set in storage account, and it's under here. This is what I meant when you're not meant to be, it's in JSON format. So all these, I'm just zooming. If someone can see that. So it's quite messy here. These are all the module sites within the Terraform that we deployed. I deployed previously. You see all these. So you're not meant to really touch that unless you have more advanced skill. So I will pass you to my colleague Mark, who will help demonstrate about some Bicep.
I'll give it a go. All right, let's get rid of all this Terraform rubbish. Right, okay. Well, how do I scroll this? Oh, you've got your trackpad there the wrong way around. I can't scroll. Right, okay, so say you want to deploy a VM to Azure in Bicep, which generally involves deploying not only the VM, but also the network security group and the storage account with the hard disks and the VNet and stuff. The way you would do that in Bicep, you use the Azure CLI to say, give me a deployment group. In this case means I'm going to deploy just to a resource group, but you can deploy to any of the other scopes as well, like subscriptions. And then all I say is create. And then all I need to pass to it is a template file, the actual root of the Bicep, so the main Bicep file there, and then some parameters to say, like I say, in this case, I'm going to deploy it to my development environment. So, I'm going to give it some dev parameters. I've put what if on the end here. That effectively just says, go and look at Azure, tell me what the differences are. What would actually happen if I did this full deployment? Because I don't have time to deploy a whole damn sort of damn thing at the moment. But oh, so easy. There we go. So yeah, basically, if I hit that, then that will go off, and it should start spinning any second now. If it doesn't, we'll ignore it because it doesn't. That's not very exciting.
March.
Oh no. Oh, yeah, of course.
Yeah, the change directory.
You'd think a Mac would be faster at finding out that there wasn't a file there, wouldn't you? But yeah, so it goes off. It goes and looks at what's actually in Azure already, compares that against what's in the Bicep, and then will tell us in a minute.
Should we show them a cool trick in Bicep? Okay.
Yeah, we'll do that. So yeah, you can see there, a bit like what was happening before with Nick's stuff. It lists all the things that it's going to change. In that case, it's going to create 7 resources because there's nothing actually up there at the moment. So yeah, how does that work? First of all, that's our main.bicep file. I'm just going to close that so you can see the full structure here. So there's a main one at the top there, and then in this module section, you can see there's the actual things that we're going to create. So there's a virtual machine, virtual network, storage account, and NSG, network security group. And here is our parameters.json. So you can see that is still JSON there. In this case, we're just feeding in the name of the VM and the password. Just to show you that you can actually do passwords securely. You can also, if you've got your password stored in a key vault, you can actually do a reference version with the key vault here, so you don't actually have to have your passwords in plain text in your non-demo environment. But yeah, so you come in at the root here. We'll get rid of that. Oh, no, I meant that. Go away. So basically, the structure of this file is we have here the various parameters that we want to pass in. So there's a simple string at the top there, which is a VM name. There's one here, which is the password, which we're going to say is secure and has to be at least 12 characters. Then there's a size of the VM where we can give it a list of potential sizes. And there's one here, which is the location, so like might be North Europe or whatever, which we can actually pull directly from the resource group that we're deploying to without actually having to, so we can override that, but we can give it a default value of wherever our resource group is. And then down here, again, we've got various variables, so we can set up sort of the things that we might want to reuse later. We can also use functions in here. So in that case, we're saying that the storage account name is going to be the lowercase version of the virtual machine name with storage added to it. And then down here, what we're doing is pulling in those 4 module files. Now, we don't have to do it with modules. We could just literally dump all the code into one file, but it makes life a lot neater if you're all in 4 files. And if I go and look at one of these module files, you'll see it's a very similar idea. You've got parameters at the top, variables. And then down here, rather than necessarily calling down to more modules, you've got the actual resource or resources you want to create. So here we've got a virtual network, which we're going to create. So we give it the location and the properties. And then within that, we can define sub-resources like, in this case, subnets and stuff. This is the thing that we saw earlier in the thing. You can see I want to return out, a subnet ID from this module so that we can use it somewhere else. In Bicep, all we have to say is vnet subnet ID. If we were doing that in the equivalent in the original ARM templates, we'd be saying reference resource ID, magic string, variables vnet name, 2022.subnet0.id. And by the time you've done that a few times, you don't ever want to do that ever again. And you can see there, it's not a great format. But yeah, so at the end of the day, we've got some very simple stuff here. A main thing, some parameters that we pass into it, some modules, one or more, and in each of those, we get sort of a list of resources that we want to deploy based on the parameters and variables that we've got in there. So nice and easy, very simple. Just a little extra thing. If you're in the main Bicep there, and if this is working, as long as you've got the Visual Studio Code extension installed, you can actually tell it to visualize, and it will show you there exactly what resources are going to be created. Another useful thing to know, if I want to add an extra resource in here, then if I want to add an AKS cluster, I can just say, give me an AKS cluster. Hey presto, one AKS cluster ready for you to fill in all the details for. So that's a neat little trick. Anyway, with that, I shall hand back to Nick, who knows how to drive his Mac.
Okay, so I'm going to show you a bit of benefits of Bicep and Terraform. So I'm going to talk about some benefits of Terraform. So Terraform is more portable and it's easier to move to another. You need to know one language that go to multi-cloud. So like you need to, if you want to do AWS, you can transfer it as well. It's just very similar. You don't need to know much. And always use more to standardize deployments. So when you reuse modules, when you use components a lot, like different modules, like AKS cluster, you always want to use modules, create modules for it, repeatable deployment. And it's also a good thing because when you map resource using state file, you can track your resource right there. You're able to use ability to use like a new provider, recent provider like Azure API, which is now known as Azure API Export. Between that one provider connect to Azure API service. So it's similar to Bicep with, but it will give you new features of Azure by using the API. And I recommend always pin your module version or any provider version, just in case of breaking change that could damage your code as a repo. So my colleague is going to talk about the benefits of Bicep.
Yeah, so one of the benefits of Terraform is that it has a state file. One of the benefits of Bicep, it has no state file. So yeah, if you prefer to actually work with the real world and the real stuff, then Bicep is better because it gives you that ability. Because it's the native Azure thing, it knows about everything in Azure. So as soon as a new Azure service comes along, Bicep already knows about it. I mean, Terraform isn't bad. It usually gets it pretty quickly, but if you're working with a preview thing, then you'll want to use Bicep because it will know, it will always be up to date. It's got the nice module functionality there. It's pretty flexible these days. You've got lots of ways of referring to other bits of your Bicep, so it's all nice and easy. Compared to ARM, because it's an actual real programming language rather than just stuff that's been plunged into JSON, all the extensions like Visual Studio Code are a lot better at being able to parse it and understand it and give you help around it. And if you're really excited as well, then you can actually start, use preview features of Bicep, because they do keep working on it. So, you can actually just in the config say, give me all the fancy new stuff, even if you haven't quite tested it yet. So that's the benefits of Bicep, and yes, I'll hand over to you for the rest.
To get started with Terraform and Bicep, I would recommend you always use version control like Gates, whether you use VS Code or Visual Studio. And also you can install HashiCorp extension and Bicep, and recommend those two are the blog that I mentioned to get started. And to get started with Bicep, you recommend a blog by Allan, which does like his repo is awesome, Bicep, Azure Bicep, with a list of like community videos, community members, community blog, everything. So it's very popular. And there's also Bicep on Terraform MS Learn. You can also scan my barcode, which relate to my blog, link to my blog, in order to get more data, more resources. Okay. So if you've got any questions, so I've also added a next slide because I'm talking online with how to use reusable modules with Thomas. So if anyone wants to know more about it, check it out. So I'm talking next Thursday at 11 p.m. online. Any question?
We don't have any questions in the chat, but if there's any in the room, we'll happily take them. One for Will.
So with modules, I know in like the Bicep world, if you want to share those modules across different organizations, there's Azure Container Registry. What would be the best way to do that in Terraform? Because I know Terraform has a concept of a registry, but is it something that you can use in Azure? Or is there a resource, say, maybe even Container Registry or Azure Storage, I can upload my modules and then other developers in my organization can just pull that down?
No, but then if that's why we use the multi-repo thing. So if we have a modules on another repo, we can just pull it through Meadow. We can call that module using Git, or we can call it through an external, like call that repo.
Right.
And then we can use that if we have a registry there as well. Although we use the ACR.
Okay, all right. Cool, awesome. That's all I had.
Hi, thank you so much for your talk. Out of curiosity, do you have any feelings towards CloudFormation, the Amazon version?
I would say CloudFormation is pretty similar to Bicep. You know, it's the Amazon version, or ARM is the Amazon version of Cloud, the Microsoft version of CloudFormation, whichever way you want to look at it. But yeah, it has similar benefits, compared to Terraform, really.
Can you use Terraform, say, to do cloud agnostic implementations?
You can debug in Terraform, track the logs. So you can like turn verbose logging, he does log. But then for if to hook it up with like, you can use like Azure Log Analytics workspace for that. That's what you mean?
If you're saying, can you use it to use the same thing to say, okay, deploy a VM to Azure or deploy a VM to AWS, then no, but the AWS people and the Azure people can use the same, same basic tool set. So that's where you gain, is just by having a shared tool set across all the clouds, rather than specifically having an abstraction layer over what it is you're creating.
Fantastic. Okay, thank you so much, Mark and Nicholas. Let's give them a round of applause.
I didn't want to say at the start, but that's the first time that Nick's actually done a talk in front of an audience.
Even bigger round of applause for Nick. Well done, well done. Okay, coming up next, we have Alpa, who's going to be talking about Azure Data. Okay, and we are back with Alpa, who's talking about sentiment analysis using Azure Data Factory. Alpa, over to you.
Hi all, thank you and welcome to my session. Sentiment.
Go.
Thank you. Thank you all and welcome to my session, Sentiment Analysis using Azure Data Factory and Azure Cognitive Service. In this session, we are going to apply a sentiment analysis without any prior knowledge of maths, data science, or machine learning, or without writing a code in programming language like Scala, Python, and Java. This is purely no-code or low-code solution using Azure Data Factory and Azure Cognitive Service. So this is me, I'm Alpa Buddhabhatti, and I'm working as a lead data engineer, as well as I provide training as well. You can find me in GitHub, Twitter, LinkedIn, GitHub, Medium, and YouTube as well. So let's start with today's agenda. So today's agenda is divided into three main parts. In first part, we're going to see a very quick overview of Azure Data Factory. In second part, we're going to see a quick overview of Azure Cognitive Service for language, and then we're going to see a demo. So Azure Data Factory. So what is Azure Data Factory? Azure Data Factory is a cloud-based data integration service that orchestrates and automates the data movement and data transformation at a scale. It is also Azure Platform as a Service, and it's a serverless. Because of these two reasons, you don't need to worry about compute infrastructure, software installation, web server configuration, or implementing your monitoring tool or similar things. Azure will do it for you. So you can fully focus on implementation and you can build it very quickly. And because of the above two reasons, you only pay for what you have used. So for example, you have Azure Data Factory and you have more than one pipeline. Let's say you have 100 pipelines. So if your pipeline is not executing, then you won't get any charge. However, you get a small amount of charge for storage, which can be negligible. So you only get a charge if you execute your pipelines. And last but not least, it's a low-code or no-code solution. So you can build your pipeline very quickly by just drag and drop components and setting few properties. So this is a quick overview of Azure Data Factory. Now let's see a second part, which is Azure Cognitive Service for language. So for sentiment analysis, I have used Azure Cognitive Service for language, which is a text analytics, but you can use audio or video data as well. If you like to apply sentiment analysis on your audio data or video data, you can do that as well. So first one, sentiment analysis. So for that, we have used Azure Cognitive Service for language. It applies analytics, text analytics on your text in a big paragraph or big documents. Then it extract your text, it classify your text and understand the text within a documents or paragraphs. And then it applies a sentiment label, positive, negative, or neutral. And this you can do it using the natural language processing technique, which is used inbuilt. So you don't need to worry about that at all. And you can use it by no-code, low-code way, or you can use a code first. So here you can use a REST API or SDK in your C# or Java or other programming language. So this is a very quick of sentiment analysis. And this is the third part, which is a demo. So for that, let's see high-level design. So we have Azure Blob Storage. So first we create a blob storage, and in our blob storage, we have a container, which is a feedback that's in container. And you can see I have one file, but you can have more than one file, which can be CSV or can be mixed like JSON file as well. So I have a file in my blob storage. Then you need another Azure service, which is Azure Cognitive Service for text analytics, which you can create by few button clicks away. Then you have a Azure SQL database for store the results of your sentiment analysis as a sync data source. And then you have Azure Key Vaults. Azure keywords I have used for two main purposes. One, security, and another one to store in a central place. So if you have a more than one Azure services, for example, you have two systems which using your SQL database, Azure SQL database. So if you're going to change your password in a database, then you have to modify both systems. But if you use the keywords, then you only need to modify in a keywords. So that is another purpose to use the keywords. And then we have Azure Data Factory. And inside my Azure Data Factory, I have a pipelines. So my pipeline reads the data from Azure Blob Storage. So for example, we have a CSV file, which is of customer feedbacks. And for example, it has 100 records. Then it will read 100 times. So it will pick each and every records from that file, and then it pass to a sentiment analysis. Then sentiment analysis apply a sentiment on your that record or customer feedback, and then it return a sentiments, and then we use some transformation, and finally we'll store the result into Azure SQL database. So this is a high level design. So before we see demo, let's see how you can integrate Azure Data Factory with Azure Cognitive Service. So you have Azure Data Factory, and inside your Azure Data Factory, you have web activity, but we have another Azure service, which is Azure Cognitive Service. So you have two Azure services, and then you have a web activity in your Azure Data Factory pipeline. So here you are passing the URL and key of your cognitive service, and then it will apply a sentiment analysis, and it return back to Azure Data Factory. So here you're passing endpoint, which is URL of your cognitive service. You're passing the key, and you're passing the message and header information. That's it. It's very easy. You can do that. So now let's see a demo. So we have used Azure keywords. So this is my Azure keywords, and it's hold the secrets here. So I have Azure Blob Storage connection string here, and I have Azure SQL database connection strings here. And only one thing you need to remember, if you use the keywords, then you need to provide a access policy. Then and then your Azure Data Factory can access that secrets, otherwise secret is not visible. So here you can see that I have applied access policy. So my Data Factory is here. So that is Azure keywords, and next one is blob storage. So this is my source data source. It's hold here, and you can see that I have three containers for this demo. So this is feedback desk in containers, hold the source file, which is a customer feedbacks. And here you can see that this is a sample data, but in real time you have millions of data here. So you can see that I have a customer ID, I have a product and feedback. It's like ADA for SQL database or whichever, like, product and feedbacks as well. So these feedbacks I'm passing into sentiment analysis. So that is the feedback source. And you can see that I have a staging container, which is at the moment empty, and it's hold the sentiment results here. And I have one more container, which is a feedback container. And here I would like to store the aggregation information, like how many feedbacks are positive, how many feedbacks are negative, or how many are neutral. So you will see summary here. And I have given a name like this way because I would like to use the same pipeline for another business outcome as well. So that's why I applied folder structure is like this way, like in, staging, and main container, which is feedback. So let's go to here. This is Azure Cognitive Service. So for that, you just go to portal and you search Azure Cognitive Service, and then you will see that here is a language service. So for text analytic, you creating a new Azure Cognitive Service for language, which is very quick by just clicking here. So I have already created. So you can see that this is the language cognitive service. And here you will see more information. So you can go to studio as well here. And you will see there are a few other purposes you can use that. You can use this for extract information, classify text, and as well as understand the question and language as well, and summarize big paragraphs or text as well. And you will see more information here as well. So this is Azure Cognitive Service. And then I have a SQL database for storing the final results. So at the moment I don't have that feedback tables, but once I run my pipeline, you will see here new table. And this is my Azure Data Factory. And here you can see that I have a link service. So I have a 4 link service, 1 link service for key vaults and other 3 for source. I'm not using this one for this demo, so other 2. So this is blob storage. So you can see that I am now connecting with key vaults. So here you're not able to find which storage account I have used or anything else because it's secure. And so that is a key vault, and this is not blob storage, and this is Azure SQL database. And here you also see that I have used via key vaults. So here you cannot see that which database or which server or which user name or password I have used. So this is a link service. And now let's see pipelines. So this is my pipeline for sentiment analysis. And you can see that I have this lookup activity which read a file from blob storage. So if that particular file will be read, and if it says 100 record, then output of this activity is 100 records. And then it's passing it's passing all record into for each loop. And for each loop run iterative way, and it's passing each and every record into a sentiment analysis. So here I have used, this is a web activity, which is calling the sentiment analysis. You can call here ChatGPT as well, because basically you're passing the URL and key. So here you can see that this is a URL of my cognitive service, and I'm selecting method. And here, this is the important things, because you need to have a proper structure. So this is the way you need to pass. So this is a predefined one, and this is a language. So as it's supporting more than 90 language, so you have to select which language your text is. So here is English language, and then I'm passing the ID as a customer ID. And this text is actually a feedback. So I'm passing here feedbacks which customer has provided. So that's it. And then is apply a sentiment analysis and store the result into this variable. And this is the important thing. This is the key. So in your cognitive service, when you create, it will create 2 things, key and endpoints. So this is very important things. So this is a key, and this is the endpoints. So these 2 things you need if you like to call your cognitive service from Azure Data Factory or Azure Synapse Analytics via no code or low code way. So let's go to here. And then I'm finally storing the result into Azure Blob Storage. I have again here used a web activity. You can use a copy activity as well. And I have this date variable to give a suitable name of my file, like file name underscore date, current date times stamp. And then I have used a mapping data flow to do some transformation, because I would like to join output of my sentiment analysis with input my original source. So that's why I have used a mapping data flow. So this is a mapping data flow, and let's zoom it. So you can see that here I'm joining 2 different data sources. One data source is CSV file, which is original file, and this another one, which is output of my cognitive analytics, which is a JSON file. I'm joining them based on a customer ID, and then here I'm doing aggregation, because I would like to know how many feedbacks positive, how many negative, and how many feedbacks are neutral. And then output I'm storing into Azure Blob Storage, and here I'm storing output into Azure SQL database, which is a final output. And this is a mapping data flow, and it's a very easy. You can add any, see, these are the old transformation. You can very quickly add by just clicking here. So now let's run our pipeline. It's starting integration runtime, so it may take some time. I forget to turn it on earlier. Let's see how long it will take. And this is the Azure Data Factory pipeline. While it's doing, I can give, oh, it's done. Okay, so let's run now. So now my pipeline is running and I'm specifying spec code, which is my business outcome for feedback, and I'm specifying file name. So now it's looking for that particular container, which is this one, feedback dash in container, and it's looking this file, and this file has 8 records. So that's why it will return 8 records. So if we see here, so here if we check, then you will see it has the output of 8. And so my for which loop run for 8 times, and it's pass each and every time feedbacks, customer feedbacks, and it's call a sentiment analysis, and then sentiment analysis return a results in a variable which is here. So you can see that this is append variable. This is the inputs, and so now it has run file into blob storage as well, which is output of sentiment analysis. So if I check here in staging area, you will see there is one file which is created recently, and it's a JSON file. But here you only see the customer ID and sentiments. So that information is not much useful. That's why I have used a mapping data flow for join original source. And so this is aggregation information. So here I will see how many feedbacks are positive and how many negatives. So 3 positives and 5 feedbacks are negative. And if I go to my database, which is here, you will see that it will create a new table here, which is this. And if I select here, you will see there is 8 records, and you will see the sentiments as well. Yeah, and now let's go back to here. And this pipeline also has finished. In Azure Data Factory, you can check outputs by just clicking on this out arrow. So if I go back now, so I think with that, I would like to thank you for attending this session, and I'm open with questions.
Fantastic. Thank you, Alpa. If there are any questions for our online viewers, make sure you put them in the chat, and anyone in the audience as well, you're welcome to ask. We can pass the microphone around. Okay.
Hi, thank you so much for your talk. Are there any particular starter projects that you think are good ways of making use of Azure Data Factory? I'm someone who's heard about it, but haven't really made good use of it. Was there particularly an idea that you think would be a good starting place? Thank you.
Yeah, so for Azure Data Factory, you can use for data movements and data transformation. So if you like to move your data from on-premise system like SFTP or SQL database to Azure Cloud, or you can use like SaaS system, for example, CRM 365 or Salesforce, or you can see like other cloud service, for example, Oracle or AWS or Google Cloud. So if you like to move your data from one source to another source, you can do it very, very quickly by selecting source, selecting few properties, and that's it.
So migration.
Yeah, that's it, one thing. Yeah. And also you can do data transformation. You can do it very, very quickly using the Azure Data Factory. So if you like to apply some data transformation, you can use Azure Data Factory.
Fantastic. Any other questions? No? Cool. Well, let's give Alpa a big round of applause. Thank you so much. Okay. So we are now going to start our next and final virtual session of the day. And this time it's going to be Unleashing the Power of Code-Driven Virtual Desktop Deployments by Jake and John. Let's just dial our speakers in. Hey both, I think you're on stream. Can you hear me?
Yep, loud and clear. Hello.
Fantastic, and we can hear you. Thanks so much for joining. And whenever you're ready, take it away.
There we go. Ready?
Yep, all good my end.
Awesome. That's great. Just want to start off by just saying massive sorry for not being there in person, but yeah, trains are a major issue today, obviously because of strikes. I'm sure some of you are in the same predicament as us, but we thought we would get there on time, but get there today, but there was literally no trains for me, so I couldn't. So just wanted to introduce ourselves quickly and today's topic. So Jake, oh, that's fine. It's unleashing the power of code-driven virtual desktop deployments of AVD in Windows 365. That is not a ChatGPT title, I promise. But yeah, here we are. We're going to be talking about code-driven deployments with both AVD and Windows 365. Jake, would you like to introduce yourself quickly?
Yeah, thanks, John. Hi, everyone. Nice to meet you. Jake Walsh. Well, nice to meet you virtually anyway. I'm sure my face appearing on the screen is just what everyone wants on a Friday afternoon, but here we are. Jake Walsh, I'm a cloud solutions architect for CDW. Lucky enough to be an MVP, HashiCorp ambassador and Citrix CTA. Pretty active on social media, do a bit of blogging and stuff as well, so do feel free to connect. If you see anything that we present on today you'd like to chat about or like a bit more info, please do feel free to reach out.
Awesome. So yeah, my name's obviously John Jarvis. The other one in the duo, dynamic duo. I'm a principal architect at Cecidian. Me and Jake used to work with each other up until last Friday, where I'm now a Cecidian employee. You can catch me on Twitter on John Jarvis or LinkedIn specifically at John Jarvis UK at the end. I'm also a Microsoft MVP. Been an MVP now since the 1st of February. But yeah, you can catch me on YouTube, LinkedIn, all that stuff as well. So that's just about us. So some key points for today and what we really want to highlight and really drive home for everyone watching. So first of all, we're going to go through and do a little bit of an AVD versus Windows 365 overview. We'll be talking about use cases, when to use which, and all that good stuff. Jake's then going to dive into using code-driven apps, why use it, what tools are required, some methodologies behind it, and some tips and tricks. We normally do a little bit of a demo on it, but because of time, we're going to try to limit that as much as we can and make sure that we are within time frames. But we can't promise anything. Just wave your hands to us, shut up if you need us to. But any questions, obviously online, feel free to whack them at us. We love a question, and people in the audience shout, scream, do whatever you need to do. I think we can hear you. Cool. So first of all, I'll be going on about AVD versus Windows 365. So I don't know if everyone was like me when Windows 365 was first released. I was just kind of like, what's the need for another virtual desktop solution within the Microsoft ecosystem? But there's been just lots of use cases of it since. So what is it? First of all, it's a desktop as a service. So unlike AVD, where we're going to be managing quite a lot of backend ourselves, Windows 365, you can just deploy the cloud PCs directly to users and not have to worry at all about the management of it whatsoever. So it's high performing management. If you notice in the background now, AVD and Windows 365, the product teams are now under one group, under Scott Manchester, I believe his name is, at Microsoft. And it's basically one team now working on both ends. So it's now a lot better than what it was when it first came out. Cost effective, again, there's lots of comparisons when it comes to cost with AVD and Windows 365. But when you're looking at having a cloud PC on constantly, so 24 hours of the day, then it becomes a lot more cost effective than running AVD virtual session hosts constantly. And it's highly secure. It's using everything within your Intune space. So all of your security policies and stuff can obviously go straight over to Windows 365. And we have two deployment choices. So business deployment and enterprise deployment are completely different. So business deployment, you literally give a user a license and bam, it just creates a cloud PC for them. Don't have to do absolutely anything, no policies or anything. It's just give them a license, off it goes. Downsides to it, you don't get any kind of Intune integration, and the integration in general with everything is quite minimum. I believe that's up to 300 users only as well. With enterprise deployment, you get a lot more granular details into it. You can put in your custom images. You can start putting in Intune policies. Conditional access is obviously a lot better. And yeah, it's just a lot more secure. I'd kind of recommend anyone to kind of use that enterprise deployment method rather than a business deployment. I guess there will be some use cases for some other things. So I spoke about cost a little bit earlier. So it's a fixed price model. So AVD, you will be using, you'll be paying for what you use. Windows 365, it is subscription based. You buy X amount of licenses per user per month. And just like your Microsoft 365 E5, E3, all of those licenses, it will be exactly the same. So it's a lot easier, obviously, then to predict future consumption, how much it's going to cost over 1 year, 3 months, over to a year. That becomes not a finger up in the air and hoping. It becomes an actual fact of what you're going to be paying. Just thought I would note some things to come. So boot to cloud is coming soon, and that's going to be a massive feature where you can boot your device straight into your cloud PC. So if you're looking at using old hardware or just repurposing hardware, which isn't very good at the moment, it's really good for that. Shared desktop environments, it will be amazing for that. So imagine you're doing a project, or you're working on a hospital ward, and you have 5 PCs scattered around that ward. All you need to do is have those users then to log off one PC, log on to the other. It'll be exactly the same experience, and because it'll be exactly the same cloud PC in the background. Windows 365 switch as well is coming. Not too sure about this one and really the use cases, but basically you can switch between your local PC and your cloud PC at the taskbar. Again, it might be if you need to use like some higher end CPU and RAM, and you need to switch over to your cloud PC. It's going to be out soon. That was it. Both of them were it. Jake was a bit worried when I put them in that I was on that NDA, but we're not. It was in Ignite, so we're cool for that. So, kind of spoke about use cases a second ago. It's really good for small to medium businesses. I wouldn't really use Windows 365 kind of at a large scale. I think that's kind of where AVD really becomes part of its own, especially when you've got when you've got pooled session hosts and
Hey there, John. I think we seem to have lost your audio.
Can you still hear me okay?
We can still hear you.
Yeah, no worries. I'll just progress once John gets reconnected. So we'll just cover off what is Azure Virtual Desktop AVD. So obviously most of you will be aware of AVD. Obviously you can deliver Windows 10, 11 server desktops apps from any Azure region. As many of you will be aware as well, you've got built-in security using the wider Azure platform. So integrations with things like Sentinel, Monitor, all of the other tooling built into the platform as well. Obviously, one of the big benefits around AVD is that ability to deploy sort of en masse and to scale to very large numbers as well. So to scale out globally, to take images, something we'll talk about today, and scale those out across multiple regions, multiple host pools, you know, groups, that sort of stuff. And obviously, the reuse of existing licensing to reduce cost is quite a big factor as well there. I'm not sure if you're back with us, John.
I should be. Can you hear me?
Oh, yeah, I can hear you now. Yep.
Okay. If you just run back one more time, I was in the flow of talking about
temporarily there.
I was in the flow of talking about Frontline. So Frontline, Windows 365 Frontline's just been released. So really good for you know, shops, shops, healthcare, all of that stuff where you've got shift workers. What you can do with Frontline licensing is you can share one license between 3 people. So those users will have to be running not concurrently. What's the word? Not concurrent, one after each other. So a cloud PC will get spun up for one user, that will get shut down and be spun up for another user. So if they're working, I think it's 8 hours, up to 8 hours a day, they can run off and run on and share one license. I think the cost will be slightly more than a normal Windows 365 license, but you are condensing costs there by using Windows 365 Frontline. So just thought I'd bring that up quickly. There you go. You can go.
So I'll just, we've obviously covered off some of the AVD sort of background, but let's just have a quick look at the use cases. So enterprise organizations tend to be sort of key candidates really for AVD, particularly those interested in the automation space. So scaling up, scaling down. A lot of the work I do is around sort of scaling out virtual desktop environments as well. So thinking about business continuity, DR, additional regions, you know, opening new offices in new locations and getting that environment scaled to those as well. Integration to the wider Azure ecosystem is obviously really important for most sort of AVD customers, particularly for things like access to line of business apps, you know, line of business systems, other services. You know, imagine you're a large enterprise and you have all of your line of business apps hosted in an Azure region. Well, putting AVD in that region makes logical sense to provide the remote access needed. Usage with other Azure cost options as well. I briefly mentioned that a moment ago, but things like reservations, savings plans, you know, automation for scale up, scale down as well. Couple of the really important use cases I see. So business continuity planning comes in a lot, you know, having an AVD environment that can be spun up quickly should there be a disaster in an office or something like that. Sorry, I should just mention these are in addition to the general sort of AVD use cases we see, but also things like high-end graphics. So N-series virtual machines in Azure, you know, the reality is that a number of years ago, the idea of doing CAD in the cloud was kind of, yeah, that's not really realistic, but it really is the case now that that can be done, and it can be done very well. And imagine that sort of scenario combined with, you know, very fast storage in Azure, you know, a service like Azure NetApp Files or Azure Storage or whatever else it may be. That's a real possibility now. Also worth noting that a mixed approach of apps and desktops is a very typical use case. You know, perhaps there's just one line of business app that, you know, is difficult to get a client installed or won't communicate securely over the public internet or something like that, and you need that application published, you know, in its singular form. Well, AVD again is another great use case for that as well. So just briefly going to cover off why you would use code-driven deployment. You know, why are these two strange chaps taking up your time on a Friday afternoon to talk about this? I think it's just important to understand that background. Yeah, story of my life. So what is infrastructure as code? Now, obviously, Nick and Mark touched on some of this earlier as well, but for us, it's kind of a key part as well. So it's a method of managing and provisioning infrastructure resources via code. It's repeatable, it's scalable, it's also very easy to share it, something I'll show shortly. It's usually a JSON file, so with imperative code, i.e. do this, or declarative code, build this, often integrated into version control systems, so something like Git, GitHub, you know, tools like Azure DevOps, you know, and it can be edited and managed in most of those platforms as well. It's usually not adopted on its own either. It's usually part of a wider strategy. You know, there are pockets of infrastructure as code that I see in my day job, but usually it's part of a wider push for a DevOps strategy as well. This is something that I've sort of talked about before as well. So I think there's a sort of way of looking at the benefits of infrastructure as code as cyclical. It's a benefits cycle, really. So you start with something that's, you build a template, it becomes repeatable. Because it's repeatable, it's not, me going and clicking things. The speed of deployment gets quicker. The risk becomes lower. It's more consistent. It's more reliable than clicking around and, typing stuff. I mean, if I was to try and build the same thing 10 times in the Azure portal, we'd probably be lucky to hit 80% accuracy. I'm a human being. It depends how many coffees I've had, all of that sort of stuff. So infrastructure code helps on that front as well. We talked about repeatability, but again, write once, deploy many times. And that doesn't just mean inside a business. That could be, me as an architect having a particular infrastructure I deploy for multiple customers, as an example. You can easily duplicate the environments, and guess what? That makes them repeatable. Therefore, we get quicker. The risk is minimized. It sort of goes, it snowballs and goes round and round. So I think it's just worth calling that out. It can feel like a bit of a learning curve at the beginning, but as you get comfortable with infrastructure as code, it really does start to progress, and you see all of these benefits.
So Jake, just a quick question. If you're working for an internal IT company and you're going to do this deployment once and just once only, like, is there any benefits of just going through and doing that with just code? You're saying repeatable, but what about if they don't need to do repeatable deployments?
So my answer to that would probably be that just because the production environment isn't repeatable, that doesn't necessarily mean the dev environment or the test platform wouldn't be. So the ability to quickly spin up a copy of the environment, test out a change or something like that, I think is very valuable. Also, it's worth considering aspects like documentation. Infrastructure as code, once you get comfortable with a tool like Terraform, you can look at it and read it and understand what it's doing. So it forms part of things like your documentation, but also, BCDR strategy. If the worst happens, we can redeploy this environment quickly because we have the code for it.
Nice. Sorry, I might have stole a question from the audience there.
Just a brief bit on tooling. So really, in order to deploy either AVD or Windows 365, there's in our view, there's kind of 4 tools you can use. I'm conscious as well that Bicep, there are other ways of doing this, but this is sort of how I'm familiar with. So please don't take this as this is the only way to do it. It's just the way we're going to sort of explain and show. So Terraform is going to create the infrastructure for us. Packer is going to build us some machine images. The CLI is doing some sort of pre-Terraform scripting and Azure tweaks, and then PowerShell is doing our software installations and Windows 365 deployment. Conscious most people in the room, albeit physically or virtually, will know what the Azure CLI is and will be comfortable with PowerShell. They'll understand, sort of what it is. It's been around for a while now, but Terraform and Packer may be new, so I'm just going to briefly cover those off. First thing, and a quick shout out, I am incredibly lazy. I don't like installing applications. It takes time and I get it wrong and I install the wrong things. If you want to install any of the tools we're going to show today, I'd recommend using Chocolatey. It's really good. The community version is obviously free to use, and it will do VS Code, Terraform, the Azure CLI Packer, and Azure PowerShell. So it can give you everything you need to work with the code that we'll share in today's session.
Jake, you really love Chocolatey, don't you? Like, every session, you're banging on the drum.
It is awesome. Absolutely brilliant. So just quickly, what is Terraform? So Terraform is an infrastructure as code software tool. It can interact with a wide range of platforms and environments, and it does that using providers. Providers are sort of extensions to the core product. There's 3 main varieties: the open source product, which is what most of the work I'm doing is based on. There's also a cloud version, which is hosted by HashiCorp themselves, and there's an enterprise, which is a self-hosted option. In our examples, we're going to use Terraform to create the core infrastructure that will support AVD only. We don't actually need it for Windows 365.
So back to the 3 films, Jake. Sorry, what's the best use cases for using open source over either the cloud or enterprise? Like, why would you go for one or the other?
So I think in open source, you are going to be responsible for managing versions, all of the backends, that sort of stuff. With the cloud product, there's a lot of things in that area that are managed for you. So that'll be sort of taken care of. You can use a managed backend, a state file. And obviously in the enterprise version, you can then start to get into the realms of doing perhaps things that aren't available in open source, or gives you a bit more control over it.
Awesome.
So just quickly, Packer. So Packer is actually another tool from HashiCorp. It's a tool for automating the creation of machine images. So if you think of Terraform will build you infrastructure, Packer will build you machine images. So really, why would we use Packer? Well, we can automate the creation of those machine images. So in the same way we would use infrastructure as code to build infrastructure, Packer allows us to create images as code. So I can take a template and I can build images in lots of different platforms, and places using it. Be that Azure, AWS, on premises, whatever it may be. I think it's also important at this point just to call out, it doesn't just mean VDI. Perhaps you have a build for Windows Server that needs a number of agents, a number of configurations on it. Packer can do that for you as well. It can also install software in an evergreen way, download the latest versions or go to a storage account, go to an internal repo, something like that, and install that for you. And that's done using something called a provisioner. It's also a simple JSON file. In the case of the examples I'll show you, it's very easy to read, and thus it's easy to deploy, easy to repeat, and easy to share. And it also, again, coming back to me being very lazy, it provides an image we can deploy, with minimal effort.
Back to another question. So, at what point would you kind of like? Would you recommend using Packer, getting a custom image out there? Because obviously Microsoft do provide their own marketplace with their own like image gallery and stuff like that.
So if you need to go beyond marketplace images, you need to install a number of applications or provide customizations and that sort of stuff. Packer becomes very powerful. It's sort of the ability to have a way of building an image from. So it will take a marketplace image, it will perform your installations, it will perform your customizations onto it, and then allow you to take that image and do with it what you need, is incredibly powerful from the perspective of repeatability, deploying to different regions. And to give you a practical example of that, I've worked with customers in my day job where we've used Packer to build out a template that deploys their standardized gold image for AVD. And we've then quite simply, when it's come around to changing that from, say, Windows 10 to Windows 11, we can quite literally go into the Packer file and change the SKU. So there's no need to sit there for ages, rebuilding anything. It's very, very straightforward to do that. Likewise, if that particular customer had decided, actually, we want to use server desktops, again, I would have just changed the SKU to server, rerun the Packer template, and I would have had an image built for me with the customizations I'd specified.
Awesome. All right, I promise not to talk anymore.
So just a quick bit on methodologies. I'm going to cover off some of the AVD stuff, and then John will cover off Windows 365. So just quickly, the deployment processes, as we'd said, for AVD, Terraform is sort of the background, the supporting infrastructure. Packer does the images, and then there's some tweaks using the CLI, PowerShell, the portal, whatever you want. For 365, it's very similar, but we obviously don't need that back-end infrastructure. We just need the images and then PowerShell to do any tweaks we require.
Really, really key to note that with the Windows 365 images, they must be Windows 10 or 11 Enterprise. They can't be Pro or anything like that. Make sure you get the Enterprise tag in there, Jake?
Definitely. Yeah, we lost a few hours on that one, didn't we? Just the deployment process. I know I said it was background infrastructure and those sorts of things, but this just gives you an idea of what's included.
It's also worth noting. It's also worth noting that you can do all of that stuff for the background infrastructure with Windows 365 as well. So although it is a cloud PC, you can use an ANC, so an Azure Network connector to bring it onto your Azure landing zone. So that is possible. If you really want to be a demon, you can use hybrid Azure AD join, which obviously you should never do. But yeah, again, deployment process here is exactly the same when it comes to imaging for AVD and Windows 365.
So just a very quick one on the AVD deployment. Obviously, with Terraform, Terraform code typically across a number of files, TF files as we call them, unsurprisingly, because the extension is .tf. These define the infrastructure and its config that we want Terraform to apply. And then at the time of running Terraform, those files are analyzed and turned into an execution plan to apply our changes. It's broadly similar with Packer. We start with a template. That template includes provisioners that define installations. In my case, it'll be using Chocolatey, and then the build process is triggered and it builds our custom image. Just briefly, again, conscious of time and things, quite a lot to get through on this session, but I just want to call out sort of different ways of working. So this diagram is typically how, perhaps if you start the Terraform and Packer journey, you would begin. So you would start by working on a single machine. You create your code and modify it. You'd save it in a local folder, and then you would run those, and your infrastructure and images would be created. Now that's really good. If you want to learn, if you want to grow, develop, and that sort of stuff. The problem with this type of scenario is in a business sense. So, let's say you are an organization and you want to adopt this methodology. Well, what happens if the person writing that code wins the lottery and disappears to a desert island? It's going to leave you in a challenging situation. So that is where an environment more like this would come in. And this is kind of how I would build my lab environment. Multiple people working on the environment, committing their code into something like Azure DevOps repos, Terraform and Packer, PowerShell, whatever it may need, runs in a pipeline. The state file would be in Azure storage, and then our infrastructure would be, created, updated, or destroyed. That's really good if we need to change anyone on the team, somebody decides to leave the organization, we're covered from that perspective. So
to answer your question, Jake, if I won the lottery, I'd still be at work. I love it so much.
You'd be on a desert island writing Terraform.
100%, yeah, definitely. I'd see myself doing that.
So I am just going to attempt to switch screens now and quickly show some code samples. So bear with me a second. Wow, that's interesting. So very quickly, this is actually my Azure DevOps environment. This is how I build my lab, and I have a number of sort of stages to the pipelines I use. For the foundation stage, I quite literally use Terraform. You can see here I'm doing initialize, validate, plan, and apply, doing some work with Azure Key Vault, and I'm actually then just doing some CLI work and building a DC using PowerShell. Just going back to this as well, I obviously have some destroy phases and things like that because I don't need to keep this running all the time. But when it comes to the images, I actually use the immutable image pipeline task. So this takes that template, this JSON file, and it goes off and builds me an image within the environment that I can then use within AVD. Just so it's useful to anybody sort of watching this presentation and thinking, I want to see these templates, they're all available within my GitHub repo. If you go to jakewalsh.co.uk, there's a link to GitHub in there, but everything you could need from today is actually in there. So just to give you an idea from the Terraform perspective, so this is a kind of base lab environment. You can see in the code, we've got things like resource groups here. There's a key vault here with a randomized password in it, so that's just down here. VNets are built out, and this is typical of a sort of standard Terraform deployment for Azure. I'm not going to go through all of this because we'd be here for several hours, and no one wants that. So from a Packer perspective as well, again, this repo is available if you'd like to download and test any of these files, but they're typically arranged in this type of format. So we have a builder. In this case, it's the Azure Resource Manager builder. You will need to add a service principal, and we just sort of call out some of the settings we need. So the image offer, the image skew, and very easily, if I wanted to change this to Windows 10, I could do that just by changing these values and then rerun that deployment. So it's very, very quick from that perspective. And the provisioners section down here is just where we actually use, well, in this case, I'm using Chocolatey to do some installs, and down here, I'm just running a sysprep as well. So hopefully that just gives you an idea of the type of code that would be used for the deployment of AVD in this way. I will now seamlessly switch back. Stand by.
Ah, so seamless.
Excellent. Right, it's all yours, John.
Well, it's like we never left. So I'm conscious of time. So let's jump on to the next slide. If you look at Windows 365, we don't have, except for the custom images, if we want to start to deploy some provisioning policies, user settings and stuff like that, we don't have the beauty of Terraform behind it. But we do have something called Graph X-Ray, which and Graph APIs that allows us to start building stuff out. Have you got any slides here? Should I share my screen?
Yeah, you go for it, John. Yeah.
All right, let's go. I'm going to seamlessly share my screen. Screen, window. There we go. Cool. Can everyone see that? Okay, I'm guessing you can because I can. Let's close that quickly so I don't get in trouble. But here, so something that a guy called Merrill at Azure in the identity team has created something called Microsoft Graph X-Ray, and I think it is absolutely brilliant because it just comes off and pulls off all of the Graph X-Ray stuff in the background right into your browser. So if I was to select devices, I'll start getting all of the stuff that happens on the right-hand side. So what that enables me to do is when I start to build out some scripts for Windows 365. If you've never seen it before, this is Windows 365, by the way. I can start creating some provisioning policy scripts. So if I just clear my session here, just so we can see it nicely. If I go and create a policy and just call it, oh, I've got frontline there now. That's nice. And just call it Azure demo, and go through, give it an Azure AD join type, make sure it's on a Microsoft hosted network, and go UK, enable single sign-on. Need to move my laptop so I can see the screen. Go through again, custom images. We've got a custom image that we created earlier for Docker. We can select that in there, press next, and go through the usual settings. And just press next. We won't assign it to anyone, but press create. And using Microsoft Graph X-Ray, I have now the script that I need to be able to make this repeatable. So if I ever need to go, might work for a consultancy or something like that, and you've made your best practice provisioning policy, you can go through and use Graph X-Ray to go and get your Graph API, and it makes it very nice and easy to rinse and repeat. And you can also do that for your custom images. You can do it for the Azure network connection and user settings. Again, it's quite limitless really in what it can do in the Windows 365 stuff. On other notes, really good for Azure AD activities and stuff like that. So if you've got any kind of like Azure AD activities that you're doing day in, day out, use Graph X-Ray and to pick out things you like. And what I do like about this, Jake, is that I can't make a mistake here, can I? Like, if I'm making code, I'm probably going to make a little mistake and ask Jake to kind of fix it. But with Graph X-Ray, it is exactly kind of what you've written down. As long as you've done the ClickOps correctly, you've got Graph X-Ray there to kind of help you to build out your scripts. Cool. I'll stop sharing seamlessly.
Just for anybody who's asked, I have put the GitHub repos and a link to graphxray.merrill.net in the chat. So yeah, feel free to grab those if you would like.
Awesome. I love the tool, I do, and I think Graph X-Ray is like one of the good ones out there.
Definitely. Conscious of we've got 1 minute left. If anyone has questions, yeah, happy to answer. Also, if you'd rather just ping us on social media, that's absolutely fine as well.
Thank you very much, Jake and John. That was really insightful. It's not an area of Azure or infrastructure that I get to touch so much, actually. So thank you for sharing that. There was one question in the chat. Firstly, actually, a lot of compliments for your seamless transitions there. Well done, both. One question was just, will you be sharing the repo for the code you've demoed? Is that going to be publicly available?
It is, yeah. So I have pasted that into the chat on YouTube. I don't know if I can share it anywhere else, but I will. I'll tweet something out as well. So
yeah, I believe.
Well, but yeah, it's all public.
I believe links that you put in the YouTube chat go straight into the moderation bin, so others may not be seeing that. So yeah, so Jake's Twitter will be the place to go and find that. Then it sounds like. Anybody from here in the room have any questions for our wonderful speakers? Doesn't look like it. Okay, well, thank you so much, both of you, and we wish you were here, but I think your talk was great nonetheless.
Thank you. Cheers.
Coming up now, we will be shifting over to a talk by Clifford, who's going to be looking at IoT and how you can do .NET and Azure things with the IoT space. We'll be back in 1 or 2 minutes, and yeah, we'll get started. Okay, we are back with Clifford, who's going to be talking about Azure IoT. Should we bother? Do we care? We definitely care. We'd love to hear what you have to say, Clifford. When you're ready, off you go.
Thank you, everyone. Yeah, my name's Clifford Agius, freelance .NET developer, and airline pilot as well. I'm not writing code. My talk and the synopsis that was in the session notes was all about using the SP32s, these little thingies, and a Wilderness Labs Meadow board. I can show that off. These are not working today for some reason. I'm not sure why. They're working yesterday, all perfectly. Got here, plugged it in, and don't know, but it just doesn't want to play ball. But we'll go through anyway, and I've been tasked with trying to get this talk done in 30 minutes, so we'll quickly whiz through it all. But why should we bother with IoT? I get asked this quite a lot. You know, businesses that I go and contract into, they ask me, well, you know, why IoT? What should we do it for? What is the reason? This is some slides, a chart from Statistica in 2022. You can see where we are there. 11.57 billion devices connected on the planet. You can see that chart's going up quite steeply. That's not the fact that we're getting an extra mobile phone because we want to have 2 mobile phones. It's literally IoT devices. Everything you buy now, from your washing machine to your dishwasher, in your kitchen, all your Alexa and Google devices, you know, your mobile phone, you know, you put some LED lights in, Hue light bulbs, they're all IoT devices. So that's why that's going up. I've seen other charts that I didn't put in when I was building this slide deck that are actually steeper than that, but that one looked a bit more realistic to me. But yeah, you can see there's quite a lot of devices there. But most people though, when they think of IoT, they think of Internet of crap. And they kind of, if you use Twitter, I know it's still a bit of a dumpster fire, but if you follow Internet of shit, it is hilarious. The stuff that gets put up there. So I've grabbed a few of these and put them in the slides just because I find them really funny. But if you look through that, what are you missing? You know, on your washing machine and dryer? You know, your favorite cycle is the cotton normal. So obviously you're that type of person that's got jeans and t-shirts. You know, it's a lot that can be told from how you use your washing machine. You know, you got 14 total cycles. You know, so you've used the washing machine 14 times. You should use it more, maybe. I just find it really, really funny the stuff that's being put out. Why do you need to know what your washing machine is doing? You don't. So why have they like bothered to put a microcontroller in there, which are rare at the moment? But yeah, we looked through this one. This one had me tickled, no ends. They've used Microsoft Azure IoT Central in a toilet, because why not? You know, I thought that was brilliant. The bit that really gets me though is, and I know if you're watching this on the live stream, you can't. Oh, hold on, what's going on? This was doing this earlier as well. Let me go back. The bit that really got me was only data that is logged. That tickled me. And then at the bottom in the brackets, if you hear a saber igniting, so now I'm thinking outside, you've got Darth Maul lighting up his lightsaber. Your data is now going to be logged. So if you hear the lightsaber, they're going to log the data you visited the toilet. I thought that had me in tears of laughter. That one did. My slides are not happy today. This one, a disabled lift, you know those ones that just go up and down, like kind of half a floor, you know, a set of steps in a store. This was in an airport. So now you've got to install an app on your phone to push the up button or the down button to go a few feet. I just thought, why? Why? You know, why have they gone to that level? Why not just like tap it with your elbow, or, you know, sort of put some tissues there. You can just grab a tissue and push the button with. Just don't know, but there you go. That one there. That's good. It's not just me. I can zoom in, share screen, share screen. Happy? There we go. How about that? We good, yeah? Cool. Yeah, so that tickled me as well. And everyone knows that the S in IoT stands for security. So all IoTs are really, really secure. I heard someone say it earlier as well. You saw that? Yeah, yeah. That tickled me as well, so that's why I said it, because I remembered that being told that before. So a lot of people think of IoT devices as being these sorts of things. And they don't think about how they can be used in business for tracking data. Now, good uses of IoT devices are things like tracking the trucks that are making deliveries, you know, likes of Amazon, DPD, etc. Track their vehicles now, so they know that it's 4 stops away from delivering your parcel. Like hell, is it? You know, but that's what they're using them for. So they're tracking the trucks around on a map. You know, at Heathrow, if you go into the Heathrow Operations Centre, you'll see the fact that they track vehicles around the airport, so they can see where vehicles are. It's like, well, that one's closer to that job, so we'll give them that job to do and stuff like this. So there's the sort of things that you can use, not just GPS tracking. Maybe it's, I've worked on projects with TV presenting companies tracking players around the field of play, and also for tracking data about those players, about how far they've gone, you know, how quickly they went from like standing start to running, stuff like this. So those sorts of bits of information you can glean from an IoT device, and a fairly small, light, low-cost ESP32. You can get these from Amazon for like £4 or £5 each. So they're really inexpensive devices as well. But we're going to talk about the opportunities of IoT. So we all know we're talking about the clouds. We're here at Global Azure. We're talking about Azure as our cloud of choice, not the other ones. But we know we know that it's globally available, so you can get a data center pretty much anywhere in the world except Russia now. Don't know why. But the compute resources we can spin up pretty much anywhere. And then you want to roll out your IoT. So that's your devices like these ESP32s, the Meadows, F7s are there as well. And all you're doing there is gathering data from sensors. Be it a sensor is a GPS sensor, temperature and humidity. Hello, Pete, if you're watching. It could be sensors like light sensors of the lights being left on in the building. If not, let's turn the power off to them because we don't want to waste electricity and be more green, etc. So whatever sensors you've got, you're collecting there. But now increasingly we're moving things. IoT isn't just about a small device like this that is collecting sensor data. It's now increasingly becoming an edge device. So instead of you sending the data from your sensors up to the cloud for processing, and then back down to the device to turn a switch on and off, or turn a pump or motor on and off. We're now using edge compute devices, which is fairly beefy, powerful PCs, which you're running at the edge. And then on top of that, you can then start to put your AI. So instead of having a camera, like these ESP32's got a little dinky camera on the bottom, and it taking an image, and that image is sent to the cloud, it's processed, and it says, okay, that is someone we recognize, so unlock the door to let them in. Is one of the things I've used these for, and you send it back and this unlocks the door, the mag lock of the door. Now you can do it locally, not on this because it's not powerful enough, but you can do it locally with AI at the edge. So you push it down to the edge. You don't need to contact the cloud. So you don't need to send all that data back up the cloud, which is fantastic because it drops your costs because you're doing it at the edge as we do. And then increasingly, the new things that have come out of Microsoft is digital twins, which is where you can make a digital representation of your real world. So if you're thinking of a big factory environment or a building that's got lights, temperature, and humidity sensors, do we turn the heating on or off because it's too hot, too cold? It's normally reverse. They turn the heating on in the summer and turn the air conditioner on in the winter. They always get that wrong in buildings. I don't know why, but it's something that's done. It's the law. But you can see there all the different kind of the bits that are going around, like buildings, wind farms, factories, etc. They're all potential places where you can use this IoT data, including tracking trucks, tracking your deliveries, looking at the data that's in and around your business, your office. I've seen people, start off with this and wanting to get into it. They've just had, sort of buttons on their device. I've pushed to production, and it then sort of lights up their desk and stuff like that. All these sorts of fun things you can do with it. But the problem is, a lot of companies start there and they think, right, we're going to do this. We're going to track all their trucks. We're going to know, and we're going to tell our customers where we're going to be. We're going to track our service engineers and know if they've reached that job on time. You see the likes of the food stores. They track their trucks. And they make sure that their trucks are not making delivery outside the delivery window. You get that Tesco's 15-minute delivery window. And you see the truck driver sitting out there for 40 minutes, but he's not allowed to deliver the food because he's not allowed to open the doors because that's tracked. And it's like, well, that's stupid. Yeah, just let the driver finish it and go back to the store. But the problems I have is IoT projects have a long lead time. You can buy devices like these off the internet and prototype on them and work on them, but they're typically not what you're going to push production. They're not what you're going to use out in the field. You could, it could be a great place to start, but you end up building a bespoke device. Your own microcontrollers, your own sensors, all on a little board. So they've got really long lead times because the development time, the build time, hard to scale because once you built a couple, you've now then got to do a build run of how many thousands of the boards you need. Difficult to customize because now you've built a bespoke board, you realize you want to add a little widget over here. You've now got to start again and build another board, etc., etc. And that's what typically companies look at and see, you know what, this just isn't going to work for us. Let's not do it. Other companies are a little bit smarter. They go down the route of using ESP32s, Meadow boards at the lower end, and building up to maybe a Raspberry Pi, etc. And building out their IoT stack like this to combat some of those problems. But again, you're always going to come back to that long lead time because if you build an IoT project, it isn't just about the software as developers. Who's here is a developer? There's a few hands, yeah. So, you know how to write software, but then if you're building an IoT project, there's typically going to be some hardware, well, there is going to be hardware involved, but how do you connect that sensor, a 420 milliamp, sensor, an analog sensor, etc., and connect those all up to the board, make sure you've got all the voltages and parts in the right place. So it is something you need to think about for IoT projects. This is where Azure steps in, because one of the problems you have is once you've got your board built and you want to connect to the cloud, you then think about, on these boards, they'll have like a Wi-Fi credentials. They'll then have a connection key to connect to the cloud. So I've put it on that one, yeah, and my prototype works. Excellent. The boss says, right, okay, we need 50 of those by tomorrow. Okay, so now you've got to build your program and load it on TC50 boards. That isn't really going to work for you. So what you do is you have device connectivity and management. So that'll be in Azure, that'll be things like device provisioning service. So it connects to the device provisioning service, and from there, it will get a key to connect to the IoT hub. Yeah? So you don't have to program in a secret key. You just tell it to connect to there and say, I'm device blah. And that is a known device name that's in device provisioning service. And it says, okay, you're going to connect to IoT hub 3, which is over here. And you can then decide load balancing of actually your closest device, Azure Center and IoT Hub is over there, so when you connect to that one, or actually this kind of device and all those devices connect to Europe North IoT Hub, so you can then provision the devices where you need them to be globally. Data ingestion, command and control, that is the things like your stream analytics, looking at the data as it live streams into the building. And then you've got your stream processing and predictive analytics underneath that as well. Workflow automation, that's just things like logic apps, automating, based on what that stream analytics job is telling you. You can then automate things. Actually, if it spikes outside of a certain level, shut the machine down because there's something going wrong. We're not quite happy there. Dashboards, visualizations, Power BI, So I've worked on projects where we've taken data from sensors and literally all we've done is gone up to IoT Hub. We've done no stream analytics. All it's done is just pushed it down to a Power BI, which is then displayed on a dashboard in the office for those in the office and the data center, the ops center to view the data and decide, okay, this is what we've got. That sports project that I worked on, one of the projects we did there was literally that. And they used the Power BI dashboard and screen in the outside broadcast truck just to see what was going on. So, when there was live an event, the camera people and the director and etc. could look at the Power BI dashboard and see what was going on. You also got, courtesy of Azure and IoT, pre-configured solutions. So there's lots of pre-configured like projects there that you can just literally download and start playing with, and the whole infrastructure is built for you. And what they've done is they've worked with their customers and saying, okay, well, retail clients tend to have this kind of a setup, and that'll be kind of building management, the lights, the heating, that sort of thing, as well as looking at things like the tags for doing control of stock. So that is a pre-configured solution. So that is what they would make available there for you to play with. This here is a reference architecture of an Azure IoT solution. So on the left, you've got your things, which is these, your devices, yeah. So they're your devices on the left-hand side, be it kind of a small device like this, an edge device, whereas an Azure RTOS, they connect to Azure IoT, and that then takes all your data into the cloud. You can see in the middle of there, ingestion. You got the IoT Hub, device provisioning, and digital twins. That takes it through to insights, which is where you're going to have your stream analytics and your live data. Azure Data Explorer has replaced time series insights recently, so that is your kind of warm path, hot path at the top. Cold path at the bottom is just your machine learning, where you're taking it in to process it and store it for machine learning models to relearn over the top. And on the right-hand side is your actions, and you'll notice on the right-hand side, most of those are business tools for the back office team, not the experts like us that are going to be building this system out, but it's the people who work in the office, you know, the people that are using that data to make the factory do what the factory needs to do, using that data for some sales tool, which is then going to be put in front of the board next week, et cetera, et cetera. So you can see you've got things, insights, actions is how Microsoft talk about it, but that is the kind of reference kind of architecture. And you'll take the bits that you need. You know, I always put this in front of a customer and we tick off the bits we want, and then that's kind of our path. The data is going to flow through the network. As I can't get this to work, because I don't know if the Wi-Fi didn't want to play with me, and I even tried tethering via my phone, but I wasn't happy. We're going to talk about a better mousetrap. Now, it's important to note, yeah, we're family friendly here. Sorry, we're animal friendly here. Yeah, no mice or rats were injured in the making of this project. I've got to point that out, just to make sure that no one gets upset. We gave them little safety helmets, just to make sure that they're all happy. And they got lots of cheese at the end of the project, so they're fat and happy now. But this project was a few years ago now, and it is basically a hackathon project that was run by some Microsoft interns. But it speaks to the power of taking a silly idea like this about a mousetrap and how it can be used to make business better in this industry. So we'll talk about it. So obviously it's US based because it's all in dollars, but rats and mice are capable of spreading 35 diseases. As humans, we don't like diseases. We just had a really big one, and it's not very nice. The traps are only monitored when someone goes to visit them, which means that your engineer is going out to visit what could potentially be an empty trap, or going out and the trap is so full that it's stopped catching all the other rats and mice. You know, if someone goes out to an empty trap, you've wasted that resource. And that isn't just the human resource, but it's the resource of the petrol stroke diesel to get there. It's the environmental impact of that person traveling halfway across the city to check on a trap which is empty. So there's all those kind of the green credentials that come with, you know, checking the traps remotely. If they're not cleaned out, the traps aren't cleaned out, the business that they're installed around is going to be having sightings of more mice and rats. They replicate quite quickly. So, you know, it's that problem that kind of grows because the trap's not being emptied. And obviously the smell and the stench that comes with a trap full of dead mice and rats. You can see there that, you know, the businesses or people stay away from the business. So if it's near like a food outlet, you're not really going to go in there if you see a mouse or a rat running past the door, are you? This is why all the bins are always kept at the back of restaurants. So that's where the rats are, you know, just outside the back of the kitchen, just where they should be. But you can see there, the market size is quite big, $12 billion. So it's quite a big market. So these interns took that idea, took the idea of, well, we'll give the mouse a little helmet and we'll see if we can trap them. And they come up with a solution that, if I do this. So they've got their mousetrap trigger into a Raspberry Pi. They was using a Raspberry Pi because they didn't need it to be in the field, even though a Raspberry Pi needs a lot of power. And then they go into an IoT hub, via Stream Analytics, into a database, Power BI, and then out to their future idea is a mobile app. So that is their solution, you know, fairly quick and easy solution. And we go back to this idea of things, analytics, and then actions, or insights and actions. There. So you can see on the left, that's the IoT hub section, analytics in the middle for the Stream Analytics, and then logic app at the end, Power BI, and out to a mobile app. So if we go back and break this down and put it into our boxes that I talked about the reference architecture earlier, you can see the IoT devices, not just one, but lots of them, into the gateway and the processing, a bit of storage to store the data of what traps we're catching the most, because then you can think about, hold on, we can use AI to look at, well, those traps are catching most. That one's never caught anyone, so we'll move that trap because it's not working where it is. We'll put it somewhere else. There seems to be lots of mice and rats being caught in that area of the building, so we'll move the traps over there and see if we can catch more. And that is all the kind of analytics that you can do using what is essentially a really, really simple trap going via the cloud, rather than it just being a trap that triggers and you just go, oh, there's something in that. So you can see the data that maybe someone who is looking at it from a business perspective doesn't really realize it's there. So when I go and speak with clients about IoT, they talk about things, but don't think about the extra data that is gathered. the project I mentioned about the sports thing was they just wanted to track the players on the field. That's all they wanted to do, was where are they? Because they wanted to make sure that the cameraman was right next to them to get the shot that the producer wanted. But after a few days of tracking these players, they realized, actually, hold on, we're now seeing the fact that player's gone from there to there. And that's a distance of that far. And hold on, now we know how far they've moved the ball. That's important data. So they kind of gleaned this extra data they didn't realize, but it was there in the database, sitting there, and we could then use that to actually make the show that they were producing a lot better than the competitors, which then meant they got to get more customers and clients, or viewers, should I say. So this is the mousetrap. Dead simple. It was just a switch that's plugged into the Raspberry Pi, and a little LED that sat on the top that said that the mouse rat's been caught. You can see there, you can see Tomcat's mousetraps. So you can see like an Acme one, isn't it? It's like a thing. And they've literally just put a switch that is taped on with some electrical tape. And as the arm comes across and traps the mouse, it triggers a switch, goes to the Raspberry Pi, which then gets fed up to the IoT hub, and it knows where that mousetrap is, and off they go. You can see there, it's linked there, aka.ms. So you can go out and actually look at all the codes and how it was built, and the whole project that was behind it. But you can see a simple design like this can be used with Azure IoT to get data into the cloud. And once it's in the cloud, we as engineers know what to do with that data and how to use it. Then out to the Power BI. You remember on that dashboard, out to the far right was the Power BI. This was what their solution come up with. So they had a map that shows the intensity of the buildings that were catching mice and rats, which part of the floor plan were they being caught on. Notice them around the canteen. I wonder why. How many have been caught today? 981 mice. Like I say, they replicate quickly, don't they? Time to clear. How long does it take to clear each mousetrap? And that's kind of business logic then, isn't it? It's like, well, you know, that one filled up and it was 12 hours later before a service engineer went out, cleared the mousetrap, rebased it and put it back in and turned it back on again. So you can see the kind of, you know, from what was initially, you know, how many mousetraps are going off and being fired. And, you know, you can see now you've got a business tool from a very simple idea. So I know when people go back to business and they look at this and they think about the things that can be done just by wiring it up to IoT and using really inexpensive and cheap devices like this. Who uses C#? Quite a few hands. It seems to be that side of the room. Yeah, C#, yeah. Or F# or VB.NET, because, you know, you're that crazy. I'm a C# developer, either doing IoT stuff or doing Maui and Xamarin for mobile as well. But this guy stood up, I'm not sure who he is, but he stood up at .NET Conf in 2021 and said that that .NET runs everywhere. And he really meant it. He really meant from the cloud all the way down to your device and onwards. And he even means these little 4 or 5 pound devices that should really work. And I'm really annoyed it's not. He even means these, or maybe a Meadow board, which is actually just, if I can get it out without cracking it, just that bit. The rest of it is a prototype board. So just that bit there, which are about $40, $50 from Wilderness Labs in the US. An amazing device, really, really good. So we've got C# and a microcontroller. And what a microcontroller is not just a CPU that we think of in a PC, but it's all the peripherals around it. So it's got all the inputs and outputs. GPIO is what you often hear, general purpose input outputs. So analog inputs, analog outputs. It can do pulse width modulation for controlling servo motors. They can do all sorts, lots and lots of things. Communicating with things over I2C, which is a serial protocol, etc. But there's 2 options here that we can use to take our C# and .NET skills and put it onto inexpensive, cheap devices that we can stick out in the field. So instead of having a Raspberry Pi that needs lots of power and it has to be plugged into a wall, so it needs 4 or 5 amps just to be happy, I've run these on literally batteries. There you go, there's one there, a LiPo battery. I've run one of these ESP32s off a LiPo battery and it's been in the field for a couple of weeks, quite happily, just running off that. It turns on, does a few things, turns itself, or goes to micro sleep, And this is like an inexpensive battery that's based in the back of your phone. So you can do that. You can leave it out in the field, and all it needs then is a connection to the internet somehow, and that could be over Wi-Fi, if you can get it to work. It can be over LoRaWAN, which is a long-range radio frequency communications tool. It can be Bluetooth to another device. I've done this with Bluetooth, where the only way of getting it to work was Bluetoothing it to a mobile phone. It was literally just a cheap Tesco's, like £40 phone, with big buttons on it. We just stuck that other side, and that was connected to the internet with 3G, as it was at the time. But let's talk about the Wilderness Labs board. So this is the Meadow F7. They're up to V2 now. They're just about to, they're in the RC channel at the moment. They're just about to GA. I'm expecting imminently with their operating system. But this is, you've got full fat, normal .NET 7, pretty much, is what's going to be available on that. And the way it works is the team that's behind it all used to work for Xamarin. So it uses the Mono framework underneath, and they target the Mono frameworks. You write your code, you've got all the generics, all the other bits and bobs. Obviously, what they have done is you haven't got the bits that wouldn't make sense, like, draw into a screen, because, well, there's no screen. So I don't need all the graphics libraries because, well, there's no graphics. So all those bits are taken out and in their build to make it even smaller than .NET already is. But it means that you can run on there. You have 2 chips. You've got the main ARM STM chip in the middle. You can see the one that says ARM. And then you can probably just about make out on the far left there, the one with the picture of a ball. That's an ESP32, which is the same chip that's on this little thing. And that does all the Wi-Fi, Bluetooth, all the comms stack. And the STM does all your processing. And you've got some memory there as well. And it means that you can run your main process. So you've got an ESP32 doing your comms. But that means that when they want to do over-the-air updates to update these devices, they can send down a new firmware, a new bootloader to the STM32, which will update the main processor. So you can do over-the-air updates, which is really, really cool. It means you can control your device without having to go out and trudge out to a field. I've done that many times. On farmers' projects, and you trudge out to the middle of a field to update with your laptop, and your laptop battery goes dead halfway around the field, trudge all the way back again to plug it in. I've got the scars. But comparing it to an Arduino is another kind of class of boards and libraries. They were born out of, I've forgotten the name of the university, an Italian university anyway, that needs to teach electronics. So they developed their own boards, and there's quite a few of them out there. They're great boards, but they run C, kind of not even C++. It's kind of not C, it's not C++, it's kind of in the middle. So we can't run .NET on there. There are some unsupported libraries out there, but they're painful to get working. Meadow ticks all the boxes. There's some there that they could even add to the list. Raspberry Pi now can run full .NET because .NET does run full on there as well. But you can see there's quite a compelling reason to go with the Meadow. Like I say, you can plug a LiPo battery in. It's got quite a bit of RAM. The new ones, the V2s, that's a V1, isn't it? Yeah, because the V2's got 16 meg of RAM, so quite a lot of RAM as well. Considering all you're doing is talking to a sensor and talking to the cloud, you're not running some full kind of graphics intensive library on there as well. And the way it works is they've got the micro RTOS at the bottom, then they've got the mono runtime on top of that, then they've got the .NET standard layer on top of that, and then a security layer because you want it to be security because IoT is got security built in. It's in it. Then you got Meadow Core, which is their core libraries, which is their version of .NET kind of bits on top, and then you got the Meadow Foundation, all the libraries to connect your servos and everything else to as well. I was going to do a demo, but I'm going to skip back because I'm right late on time. Nano Framework though is slightly different, and it's really compelling, and I've kind of leaned towards Nano Framework a little bit more recently because you can take any device that they support, from an ESP32 and all the many ESP32 derivatives that they have. You can take the STM chips as well, Texas Instruments. There's quite a few kind of boards and chips out there, which means you're not tied to any one device. You're not tied to one supplier, which is Wilderness Labs, for their board. You can go to any of the manufacturers and get them and use those boards and run your code in there. They do it slightly differently though. what they do is they have their hardware abstraction layer, because each board is different. And then on top of that, you have the platform extraction layer that extracts it a little bit higher level. Then you've got your CLR, which is their version of .NET. So it's not full .NET. For example, they don't have generics. And I know Jose, who looks after the project, is probably screaming now. It's like, no, he's coming, I promise, because it is coming. It's just that it's a small team, but they're having to rewrite generics to run on. I mean, these boards have next to no memory at all. You know, the Wilderness Labs had 16 meg. These are down in the kilobytes. You know, a couple of 100 kilobytes. So, you know, I think it's 256 on there, I think it is. So they've got a really small memory footprint they're trying to fit this onto. Then you have AMS Core Lib, System.net, your other namespaces, and then your code sits in the last little bit that's left over. So you can't do a lot, but you can run some really cool projects and working on there as well. So that is what we can use it for. There's an Expressive ESP32. So you can see all the different connections. The green ones are general purpose input outputs. ADCs are purple, which is analog digital converters. You've got touch sensors on there. There's just all sorts. And you can do all of that using C#, your .NET skills, yeah, and connect it to via a battery and leave it out in the field for a couple of weeks collecting data, which I think is, and sending the data up to the cloud via Wi-Fi, Bluetooth. I was going to do a demo, but again, we'll skip that. If you want to see some more, myself and some other MVPs, OT MVPs, did a, we're going to do it again in November. But every November, we've been, for the last couple of years, we've done a live stream, a bit like this, talking about IoT, flight into IoT, and that is the link back to my aviation side. And we did short haul, we did long haul, and we might do space or something this time. We haven't quite decided yet, but it's a 3-hour stream. But we take you through how to get data from a small device like this all the way through to the cloud. And then when it's in the cloud, which is literally the first 20, 30 minutes of this stream, the rest of it is what we can do with that data to eventually get it to a Power BI dashboard, how it's used in stream analytics, how you can write some custom query languages with KQL to take that data, split it up, and connect, see anomalous data within that data stream live as it comes into IoT Hub. So it's quite compelling. I'll leave the YouTube link there as well. Call to action. If you want to learn more about it, there is a certification, AZ220. It is sadly going to die. I think it's end of July, I think it is. But that's just the exam. The content, the rest of it, the Pluralsight course, and playing with a Raspberry Pi Pico, the bottom one there, and how to connect that is a good lesson to play as well. Raspberry Pi Pico, they're made in Wales. You can get them for £4 or £5, and all you need is a USB cable and your Pico, and you can start connecting to IoT Hub and playing as well. So there's even though it says AZ220, it's just so when you go to those links, you'll see it's AZ220. The exam is dying, but you can still use the lessons and learning. I don't think they're going to take that away. They'd be fools if they do. That's enough from me. Questions? I know I've gone over by 3 minutes. Promised I'd be done by 4. But if there's any questions, anyone got any questions they want to ask? If not, I'm going to hang around.
Questions from the audience? I was going to ask a question.
Go on.
You mentioned over-the-air updates.
Yep.
Which sounds awesome,
but
awesomely scary as well.
Yeah.
So what's the process of actually securing that? Like, could anybody push an over-the-air update to any of those devices?
No, it goes via the one that does it at the moment is the Wilderness Labs. So it goes via their servers, and because obviously you control which devices are connected to your account, you then control who can get access to that device and do the update. They've got a security layer around it. It's still in kind of beta demo kind of mode at the moment, but it is I've kind of looked at it and played with it, but it's still something that's being sort of sorted out. The downside to that is you're then using Wilderness Labs cloud service, whereas I'd like to be able to push an over-the-air update from my IoT Hub, which is where my data is coming in, and they're connected via DPS, etc., etc. But hopefully one day we'll get there. Good question.
Awesome.
Any others? No? Right, well, thank you very much.
Thanks very much, Clifford. And coming up now, we have our final talk. Excellent. So we have our final talk of the day. I'm sorry, but I'm really excited about this one. So I'm just going to hand straight over to Joel. Joel, whenever you're ready, take it away.
Brilliant. Well, thanks everyone for having me. It's been a really interesting day. Lots of good content. Hopefully this last one can live up to the expectations everyone's given it. So Azure Function Apps. They're really powerful, and I'm going to show you a little corner of the functions runtime that you can abuse. And there's good reasons why I've had to abuse them. So my name's Joel. I'm an architecture and engineering leader. I've been speaking for 10 years. I've been playing around with computers for 25 years professionally, but I'm a lifelong coder. I don't even dare to think how many years since I picked up a book on BASIC and started typing into an Apple II. Some background. Why even are we getting horribly nasty with Azure Function Apps anyway? Well, I work for a company called Landmark. They're a property tech business, and they're undergoing a really massive transformation project that's aligning 13 business units, 70 or 80 different applications in various spheres, and not least of which, we're transitioning everything from a whole load of on-prem Oracle systems to Azure. We're all in Azure. And more than that, because of the nature of the way we want to work with the data and keep the identity of our business units, but still have that holistic view of it all, we've gone all in on microservices. In fact, microservices everywhere, which has been great. We've got all these little services that do a sensible amount with their own data stores. There's lots of eventing between them. It's actually working pretty well. Where we've gone slightly off-piste is we have a need and a desire to be really, really resilient. Not just the normal resilience you get with an Azure Function App in that it'll scale, it'll self-heal, and yeah, you can fail it over. We actually want to be active in dual regions, at least 2 regions, if not 4. Why? Well, Landmark is not a household name, but we actually cover 95% of the UK property market, which is a big statement to make, but because we've got fingers in every part of the process, the data is there. We really don't want our banking customers, mortgage lenders, to get upset with us if our systems go down, even for a few minutes. Don't mention the fact that some of our suppliers, HMLR, actually turn their systems off overnight, but we try to work around that. So we want to be full on active. If you want to be able to fail over, load balance between regions, you need to understand about the health of your systems in any given region. Which comes to where I came into this, which is a microservices pattern, the health check endpoint pattern. And it's very straightforward. If I want to know whether a given instance of a service is up, I ask it. I'll hit an endpoint and say, are you there? Are you healthy? And it's going to return with one of 3 states. 1, it's healthy, it's available to receive requests, it's all working fine. Secondly, and this is one that's not often used as well as it should be, your service is not healthy. It's still there, it's still running, it will still accept requests, but it isn't necessarily going to process them quite as quickly as you might expect. If you're into event-driven systems and eventual processing, then that interim state isn't really so much of a problem. But if you've got systems where, yeah, I could accept the request, but I can't actually complete the processing, so you might want to retry, that's where you need to know you're in that interim state. And then, of course, they're either completely dead, non-responsive at all, server 500, or somewhere in the middle again, server 500, where yes, the instance is there, it's running, but it just is not responding. Very straightforward pattern. which you just have to implement on your endpoints. But then you end up with the problem of, I need to implement this not once, not twice, not 5 times, not 10 times. We're up in the about 100 to 150 microservices. Copied across 2 regions, automatically scaling, that we want to load balance between them. We found the problem was there wasn't a way with Azure Functions to actually provide those endpoints. ASP.NET, or ASP.NET Web APIs, it's trivial. Let's actually trust the demo gods and go and build an ASP.NET Web API with a health endpoint. So let's create a scratch folder. We do .NET new Web API. .NET restore. There's our skeleton code base. And with my reference implementation later, I've followed the same thing. All we actually have to do to get this to work, can you see the code? Is add 2 lines to the code. Services add notes, add health endpoints. Health checks, that's one. And then after map controllers, map health. Just to double check, because I don't trust myself or Visual Studio Code to actually get this right, I'm going to go and sneak into my samples. Here's the one I created earlier. There we go. Add health checks, map health checks health. Okay, apparently my screen has not been shared.
It's frozen.
That's frozen.
So if you go back to screen.
So it's this one.
Yeah, just refresh the whole thing.
Hopefully we're back in stream. Okay, so what we did was in Visual Studio Code, we added 2 lines of code. Add health checks and map health checks. And that's it. We can now do .NET Run. And if the demo gods please me, save that. And I should be able to, let's build it first, just to be sure.
Incorrect.
You're right, it isn't. Let's go to one. Let's go to the real one. It's exactly the same. Let's go up one and samples, and good thing I've got co-pilots here to help me. Build. .NET Run. What you get out of the box with this, copy that into, where's my browser gone? Paste that into the browser. You get out of the box. Should be Is in fact working. There we go, yeah. You can see up here in the corner, it says degraded, because it's a random health check. That's a health check. It's been built from the ground up. I don't even have to think about it. That's really helpful. Let's go back to the slide deck. So that was so easy. Why wouldn't you just use it all the time? Well, you don't want to use an ASP.NET Core web app all the time because you've got to host it in an app service, which costs a bit more, or a VM, which costs more, or you might put it in a Docker container or Kubernetes, and then you've got more problems. And that's why we want to, at Landmark, use a shed load of function apps. The ASP.NET was really easy. But function apps aren't the same. You're not actually running in the normal runtime that you would expect when you're running just a ASP.NET web app. You're running along the functions runtime, which doesn't support Web Application Builder, which is how those two lines set up those health checks. Doesn't also, this is a really nasty bit, support programmatic routing. You can't just say, oh yeah, this route maps to some Lambda. Doesn't exist. There's no way to do that. Even worse, you would think you could build a function stick it in an assembly, reference that assembly, and the function, the definition, decorated exactly like you'd normally build a function app DLL, will be detected. It's not. The runtime will only pick up decorated functions from the primary assembly. But it does support something called extensions. Now, if you use function apps, you'll have used these already because that's what actually gives you your HTTP triggers and your service bus triggers. And this is where the abuse comes in, because for all that framework to work, there's a couple of little hooks in the background that we can attach to that then let us really abuse and tell the function's runtime, add an extra endpoint. Key to finding this out is to actually watch a function app starting in verbose mode. Who has actually run command line function app in verbose mode? Mark, of course, because it changes your perspective on what the heck's going on behind the scenes. Let's do that quickly. Let's get my command line up here. Get rid of that. And I'm going to go to the in-process sample, which should be built. So clear. Hope we can all see this. Normally, you would start the function app from the command line with func start. When you do that, of course, it's going to do a quick build. Why wouldn't it? You'll say, using the secrets file, and then there's some endpoints. Now, this has got Swagger endpoints because I added on the Open API extension that's actually was the code, but the open source code base I was able to use to find these things out. But it doesn't tell you a lot. It does tell you can do a verbose mode. Let's do that. Suddenly we'll find it tells us a lot. Loads and loads of output. And there's some critical parts in this output, as well as all the configuration. You'll see here, initializing warm-up extension, loading the Open API extension. That's what triggered me to say, there's a way to plug in here, which you don't see until you've done it on verbose mode. And that's exactly what we're going to do to get, because that's exactly what the Open API extension does, to add in its endpoints. Code in the Open API extension is a little bit interesting in places, the way it's been done. It was a design decision internally. But what is it actually doing that we care about to be able to replicate it and put our own health endpoint on? Back to the slides. So this nasty little diagram is what you need to do to build to get an extension and a additional function on an HTTP trigger added in to the runtime. So starting at the top, there's a web job startup. In the same way that there's a function startup and an ASP.NET core startup class that you can reference, there's a web jobs one. And this is actually starting up when the function's runtime starts. So it's actually the host of your function app starting. That's quite useful because that means we can plug in to that framework early doors. That's where we register our services and our extension. Second bit is a function provider. You register a function provider. It implements a function provider. And you'll be called to say, what functions do you want to add into the list of functions that I display? Brilliant. That should be trivial and easy. Slight problem with actually implementing it is that it requires function metadata. Most of the function metadata classes that you would want to create a new HTTP function, HTTP triggered function. You can't because the metadata is internal, an internal class. There's a way around it because the function runtime allows you to define functions via JSON configuration. You can serialize a class that looks like an HTTP function as JSON and then plug it in as metadata, which is actually exactly what the Open API extension does. It's horrible, it's nasty. Why didn't they just open the things up? But it works. And it lets me set up an HTTP route to my own function app. Slight nuance, the function method must be static. That means you don't get DI. So you can't add my weather service into the code because it doesn't exist. Can't access it from a static. There's no dependency. There's no container for it. That's the third part of this, which is your context binding. This is the attribute that lets you put for the service bus to define the topics it listens on and have that injected into your method, your function method, as a parameter on the method. You can define your own ones. And the class that they inject can be absolutely anything you like. It's a bit nasty that you have to get the naming exactly right, as in including to capitalization, and don't get any mismatches. We're only going to do this once because this is going to be a repeatable thing. That was the point. We didn't want 106 implementations across 106 different code bases. So the context binding lets us put in a health context, and that health context contains the services I need. And then you just have to write a little function that implements it. So let's have a quick look at that code in Visual Studio. So I've got lots of code here. Get rid of the outer proc. You didn't see that. It's not necessary. So this is a full implementation for in-process function apps. We have a web jobs startup class, which is just defining my function provider, defining my trigger context, and adding this context binding as an extension. Just Microsoft dependency injection. You've got my binding metadata. This is a class that tells the function app how to bind another class, i.e. the actual context class, to a property. Remember I said all about how the names are required? Yeah, they are for this because you can't use the reflection code that function runtime uses because it's internal. Context binding is just an empty attribute, pretty much. Sorry, there is an attribute, that one, which is empty. which is the attribute you put on your code. This is the extension that registers it. There's not much code here at all. This is the really nasty bit down here where I'm mucking around with my own classes, and which are then, yep, you're absolutely right, down here, look, serialized as JSON and then added as binding metadata from the JSON object. And finally, I've got a function, static async function that takes my health endpoint trigger context, because that's where I get the service I need to implement it. So this function app in process that we ran before doesn't have a reference to my project, my health project, which is why the URL doesn't appear here. I'm going to flip to code because I find that much easier for editing project files. And I'm going to just uncomment out project reference. In project, in the right place. Build it, it'll go and build out the project, including the reference to my other library. I should be, from the start, minus posts. If it got to that point, I'm absolutely delighted because it means it's all worked. But you will now see, if we scroll back here, go up to, you will now see it's found my startup extension. And it's initialized it. And it's now found an additional function because it was reading the function metadata faked from my function provider for my health function. And so now, my in-process Azure function app, where am I going, left or right? There we go. The health endpoint. I've tweaked the implementation compared to the reference the ASP.NET Core one, because it's useful to actually know what's going on. So we're degraded because it's freezing. No, we're healthy. Oh, it's too hot. We're still dead. That's the degraded one. Not sure because it's only hot, not too hot. Okay. Nearly there. Did the function, did that demo. So what this means is, since I can package that shared library up as a NuGet package, I can deliver it, deploy it into all my function apps. They all get a health endpoint out of the box. No code, not even 2 lines of code that we had to do with ASP.NET Core. 0 lines of code, one package reference. And then I can add my health checks in. So that's brilliant. So I've now removed 100. It was actually 76 copies of 10 files from 1/2 of our code base set. That was quite an improvement. There's a gotcha. The gotcha is the functions runtime is very, very nuanced about what versions of the Microsoft.extensions libraries you use with it. You use set the 7.0 versions with an ASP.NET Core app, it's just fine, it just works, there's no problems. Function runtime, not a chance, just will not work. Hates it. Throws errors all over the place and you can't debug them. So you have to be quite careful about which versions. In this sample, it's .NET 6, functions runtime 4, with Microsoft extensions version 6.x, and it works. That's stymied me and made me scratch my head at least 3 times in the last 6 months, where I've forgotten that point. So if nothing else, that might help you at some point. Okay. The abuse can go much further. There are other ways to use this to abuse the functions runtime. If you work for Microsoft, close your ears. So one of the things we needed to do was to preload some data into some of our functions apps. And it was taking quite a long time. Didn't help that someone had scoped the data service as a scoped one, which meant it was creating a new one every single time rather than when the function app started. But actually, because of the way the function app very cleverly jits the code, or manages the code stand-up, we were finding that our load times, even though we said it's a singleton, go and preload it, wasn't actually being hit at all until the actual function was executing. Put it into a premium plan pre-warm, it still wasn't coming up quite right. We tried putting it in a timer function to say, oh yeah, every 5 minutes, make sure that this has been done. That's great, except the timer function will only trigger 5 minutes after the runtime starts, not at start and then, because it's primarily based on the cron tab. With this, you've got access to the host startup mechanism. And that is those extensions you can actually set to go do something right now, which we abused for that. Abused again because some of our dependencies turned out to have longer start times than we wanted either. The launch darkly client is a particular candidate for this because it goes and caches all the relevant feature flags given scope when the client is instantiated. It's a static constructor on the client class. Same problem. I want that to happen way before any client, any consuming code calls my function app. These are two places where Microsoft would say, go to premium plan and use the warming extension we saw before. Doesn't quite work as well, and you certainly don't get the value and benefits from premium plan. Sorry. This works. It works actually pretty well. I'm not going to demo function apps out of prop because I haven't got it working yet. My colleague texted me at lunchtime saying he has got it working, but that's in a different code base. That's because out of process, the function runtime works differently again. Still doesn't support the web application builder, and in fact, it doesn't support the web job startup either. It's got its own startup function code instead, so you've got to have two flavors. Still doesn't support functional registering. It does support functions in separate assemblies, weirdly. So you actually have to do less effort for in process. You still have to do some to get your services and your context registered. So you don't need the function provider and abusing that with the JavaScript. You can still build it. So, I think I'm on time. I'm good. I did this in 25 minutes last week, so this is still good, because I wasn't even doing those demos. So where have we got to? What have we done? Well, we've proven we can actually inject code into the functions runtime startup. That lets us do host level registrations. It lets us do pieces of work early doors. It lets us add function providers, which let us register functions that add to the experience and add to the runtime for any given function. The internal metadata models are a real bugbear of mine. That why couldn't they have been made open? Would have made it much easier. You didn't have to muck around with duplicating those classes just to be able to register another HTTP endpoint. One of these days I might get around to raising a PR on the code base and say, let's do this. But some of us have work to do. Critically, you've got to remember it's a static function method that you have to register. That means you have to do the injection via your trigger context classes. But it's doable. And I've got a reference implementation that shows you exactly how to do it. Pause while everyone gets cameras out and takes a photo. And I'll be updating that reference implementation so it works with in-proc model as well, probably next week. That's me. Thank you very much for your time. I hope you'll be informative.
Fantastic. Thank you very much, Joel. We can take a couple of questions in the room if there are any. And on chat as well, let us know if there's anything you want to ask. No?
I think it's going to be before Microsoft revoke your Azure credentials.
Well, given LAN, there's some hacking there. They are aware of it because we have discussed it with them and talked about why the startup problem was such a problem. I don't think they're going to revoke our credentials given the size of our Azure build personally. But, yeah. It is hacking. It is hacking. As I said, I think when I get time, or I might actually task one of my colleagues doing this, we're going to raise a PR, an improvement request on the functions runtime itself. So if a couple of those pieces are public rather than internal, suddenly lots of the hacks go away, because then the actual function provider interface and registration, that's straightforward. The web jobs registration, it's straightforward. Building the extension for the injection context class, that's straightforward. It's just that little bit about raising metadata. And also I was doing to create a timer function programmatically in the helper library. Don't even go there, you can't do that. So that would be another aspect where we want to feedback and improve things.
Does that not mean, though, that if you follow your method, you don't need premium as your functions, because you don't need that warm up?
You could, but, and this is the big but, you're then still limited to what the consumption model gives you. Whilst you don't get the warm up, whilst we're hacking the warm up, we can do. Actually, the premium model for some of our workloads is important for the scaling and control reasons. So, for example, whilst we want to be in consumption plan for some of our main flows in our ordering pipeline, in our production pipelines, we actually want to very carefully control the scaling and performance of those Azure functions, because we do not want them to scale out. We want to be able to have that control, and that's why those ones are going to premium plan. So we've got more control over that scaling.
Any other questions in the room before we wrap up? No? There's one.
There was just one.
Sorry. Do you know any other companies who are doing this kind of abuse of Azure functions? I mean, how exclusive is this to yourselves?
Well,
name and shame.
Name and shame. Other than Microsoft themselves with the Open API extension, I'm not aware of anyone. Microsoft has said our particular need to do, rather than do a controlled failover between regions, to really be very, very strongly active. That's unusual, but as I said at the top, it's understandable given our set. So that's where that is.
It's so interesting.
Cool, thank you.
Fantastic. Thanks, Joel. Let's give Joel another final round of applause. Okay, so we've unfortunately come to the end of our day. Boo. We've had over 6.5 hours worth of talks that you've sat through. So thank you. And especially thank you for making it all this way in person, given the train strikes and everything like that. So yeah, train strikes. Yeah, we've had a nice active audience online. You've been great as well. This is the bit where I'm going to make your hands hurt whilst you clap a lot. So I think we need to give a big round of applause to all of the speakers who've given up their time and spoken today. You've been excellent. The talks are great. Of course, people will be asking, were they recorded? Can I watch them back? Yes, you can. It's on YouTube. If you signed up via the Meetup link or the Reactor link, there's a link on there for you to go and have a look at the recording, so you can go see all of that. We also need to give a big thank you to the global Azure organizers as well, who've been helping organize all of the events behind the scenes. There's a few sponsors there too, so let's give them a round of applause. And I want to give a particular big thank you to Microsoft and the Reactor team who've let us use this space today, particularly Rav, who's unfortunately not here, but she's done a lot of work to help us make this event logistically happen. So I'll give a big round of applause for all of them. And yeah, with that, that's time. Oh yeah, well, we've done a bit, but it's fine. Thank you. Thanks everyone for joining in person. Thanks for everyone on the live stream. Hopefully we'll see you at an event in person soon, and goodbye.